technological topics in the world of civil engineering from the realm of academics and practitioner viewpoint.
Persons who are experts in the field of civil engineering.
By knowing how the development trend is going to be, it is hoped that it will inspire our students, researchers, practitioners, and academics for a new paradigm. So, we are present to you this international webinar,
The
The Future
future of
of
sustainable
Sustainable Infrastructure
infrastructure and
and
built
Built Environment
environment
after
after
COVID-19
COVID-19 outbreak.
from National Central University, Taiwan.
The Honorable Mr. Aryo Muhammad, Doctor of Philosophy, Honorary Research Associate from Department of Civil Engineering, University of Bristol, UK.
And the last one, the Honorable General Chair of Department Civil Engineering, Vocational College, Universitas Gadjah Mada, Dr. Engineering Sindu Nuranto. And of course, all of the participants in this first international webinar 2020.
Dear participants, this international webinar today will be consist of two sessions. The first session will be presented by Professor Masaharu Fujita, Disaster Prevention Research Institute from Kyoto University, Japan, and Mr. James Sullivan, Master of Science, Directorate of Technical Development for Water Resources from the Ministry of Public Works and Housing, Indonesia.
Next, in the second session, will be presented by Professor Jin Binyang, Graduate Institute of Construction and Management from National Central University, Taiwan, and also Mr. Aryo Muhammad, Doctor of Philosophy, Honorary Research Associate from Department of Civil Engineering, University of Bristol, UK.
This webinar aims to bring together academics, researchers, engineers, practitioners, consultants, and students regarding the development trends of civil engineering and its challenges in the future.
This conference provides a great opportunity for the participant to discuss, to evaluate the latest approaches, innovative technologies, policies, and new direction in infrastructure development, pollution prevention, and environmentally friendly technologies adapted to developing countries.
The honorable participants, ladies and gentlemen, we are now entering the next agenda, singing Indonesia Raya Anthem and Hymn of Universitas Gadjah Mada.
The honorable participant, ladies and gentlemen, we are now going to listen to the opening speech delivered by the Dean of Vocational College Universitas Gadjah Mada, Dr. Engineering Agus Mariono. Please welcome Mr. Agus Mariono.
So, Assalamualaikum warahmatullahi wabarakatuh. Thank you very much. First of all, I would like to say thanks to the organizing committee who has already set up this webinar, very important webinar. And I would like also express my thanks to speakers. First, my friend, Professor Masaharu Fujita, from Japan. I have already visited him, and he has already several times visited our campus. And he is a professor, sensei from Dr. Suleiman. And Professor Jin Bin Yang from Taiwan Graduate Institute of Construction Engineering and Management, National Central University of Taiwan. I have already visited Taiwan one time, and in the time that Mr. Teguh Sutibio was there. I'm very glad and very happy was in Taiwan, because I know the engineering in Taiwan is also going forward very quickly compared to other region. And Mr. James Zulfan, from the Director of Technical Development for Water Resources, Minister of Public Work and Housing Indonesia, thank you for your coming. And Mr. Aryo Muhammad, PhD, Honorary Research Associate Department of Civil Engineering, University of Bristol in UK. Can I share my short presentation, please?
Yeah, of course, sir.
Okay. Host disabled attended screen share. Can I screen? Screen my in. Hello.
Yeah, sure.
Halo, halo. Halo.
Okay, I'm sorry for the miss technical. So we will wait again for the audience, Dr. Engineering Agus Mariono, to join again in this conference.
Halo, halo, halo.
We would like to have this building, another building in Kulon Progo, and more connection with other university, with other industry to support our innovation of the student, 4.7 thousand students or 4,000 students. Every year we have about 1,150 graduated from our campus. Yeah, that way we would like to have more collaboration with all university and industries. First, we have already set up collaboration with our local network in Yogyakarta region. In the whole Yogyakarta region, we have already set up our network, and then we want to have network in the whole our Indonesian archipelago. of Things, big data, artificial intelligence, augmented reality, cybersecurity, and simulations program. So this is what very important thing that we have to discuss today. And I hope that the whole presenter and participant can discuss very fluently, and we got a good result. That was my speech, and thank you very much. With Bismillahirrahmanirrahim, I'm the Dean of the Vocational College of University of Gadjah Mada, open this seminar. Thank you very much. I give back to the Master of Ceremony. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Agus Mariano, for the opening remarks. We are very appreciate and fully support your efforts in advancing vocational college Universitas Gadjah Mada. We are now continuing our conference to the next agenda. We will hear the first keynote speech, which will be delivered by Professor Masaharu Fujita, Disaster Prevention Research Institute from Kyoto University, Japan, and Mr. James Sulvan, Master of Science, Directorate of Technical Development for Water Resources from the Ministry of Public Works and Housing, Indonesia.
Our keynote speech will be moderated by Mr. Ian Mantasa Salva Prastika, Master of Engineering, which also will directing to the next agenda. A little bit about Mr. Ian Mantasa. He is now a lecturer in Civil Engineering Department, Vocational College, Universitas Gadjah Mada. Mr. Ian teaches several courses about water infrastructure, dam engineering, irrigation, drainage, and other water engineering related courses. Mr. Ian Mantasa got his bachelor degree Okay. Mr. Ian Mantasa got his bachelor degree in Universitas 11 Maret in civil engineering at 2015, and he's become the best graduate in that moment. He's continuing his master program at Universitas Indonesia and majoring hydrology and water resources science 2019, and also become the best graduate again. Mr. Ian Mantasa also has an experience in the research field. The first one, the first one, become the research assistant in Universitas 11 Maret and rest Indonesia. Okay, I'm sorry. Okay, I'm continuing. And again, in the research experience, he's become a research assistant in first Universitas 11 Maret and Universitas Indonesia, and also Australia and Indonesia Hydrology Center. Okay. In the scientific publication, in both journal and conference paper, he got a lot of scientific publication. I will mention two of that. The first one, structural mitigation measure for flood reduction in urban area in 2020. And the second, structural and green infrastructure mitigation alternative prevent Ciliwung river from water-related landslide in 2019. For his achievement, I will mention two of his achievements. The first one, the Best Paper Award in the 11th Engineering National Conference 2017. And last one is the Best Presenter at the International Conference on Climate Change 2019. So please welcome Mr. Rian Mantasa Salvo Prastika. Good morning, sir.
Yes, good morning. Can you hear my voice?
Yeah. We would like to know how about your day, sir? How are you?
I think it's amazing. Thank you for inviting me as the moderator in the session.
Of course, sir. And now we nearly have 400 participants here in the Zoom meeting, and now we have nearly 800 participants with registered at this conference. And this moment, you will become our moderator for this session and the next couple minutes. So please enjoy, and the time is yours, sir. Thank you.
Okay, thank you. Good morning, ladies and gentlemen. First of all, let's thank God for blessing us so we can meet here in good condition and situation. In the special occasion, I will become the moderator of the first session in this international webinar. And thank you for the Master of Ceremony. Ladies and gentlemen, I would like to inform you that our Master of Ceremony today, they are students in Civil Engineering Department in the third semester. They're still in second year, and it's wonderful to have young generation in this international webinar. As mentioned by the Master of Ceremony, I will introduce my name first shortly. Okay, my name is Rian Mantasa. I'm lecturer in Civil Engineering Department, Universitas Gadjah Mada, Indonesia. Okay, dear good people, maybe I would like to thank you for your coming today. We know we are in Saturday weekend time. Usually we prefer to do entertainment activities in our leisure time instead of having heavy material in this international webinar. So thank you so much for all of you. So you still have the commitment to attend this webinar. As we know, today we conduct an international webinar entitled The Future of Sustainable Infrastructure and Built Environment After COVID-19 Pandemic. First of all, let me tell you a story. Please listen carefully because I will not repeat the story twice. Okay, in many development countries, including Indonesia, lack of infrastructure is a major obstacle to investment and development activities. Apart from the limited funds available, the acceleration of sustainable infrastructure development still has to face challenges including knowledge, human resource management, best practices, and capacity building. On the other hand, developing countries generally have abundant local natural resources, adequate carrying capacity, and local wisdom. Therefore, developing countries must reflect on the past and understand the current situation to have better and more sustainable infrastructure development in the future. To meet these challenges, it is not only the right planning, design, implementation, civil building management system, and infrastructure rehabilitation, but also a clear policy direction and strategy for sustainable infrastructure development through an integrated, multidisciplinary, and holistic approach. The global momentum for sustainable development must now lead to the practical application of sustainability techniques and science to enable comprehensive planning with maximum attention to aspects of sustainability. Okay, so today we have amazing speakers who will accompany us in the first session. First, we have Professor Masaharu Fujita from Disaster Prevention Research Institute, Kyoto University, Japan. Good afternoon, Sensei.
Ya, selamat pagi.
Yeah, selamat pagi.
Selamat pagi.
Is everything okay?
Morning.
Yeah,
How
good
are you?
morning. Okay, I'm fine here. Okay, thank you for your time. And actually, we still have one more speaker. We have Mr. James Zulfan. Good morning, Mr. James.
Good morning.
Okay, Mr. James, thank you so much for your coming. Okay, ladies and gentlemen, I think I will kick off directly the session with the first speaker. With the first speaker first, Professor Masaharu Fujita. But I will read his background first.
Okay, may I start my?
No. I think I will read your curriculum vitae first, Professor. Okay. For the background of the Professor Masaharu Fujita, his education mostly from Kyoto University from 1980, 1982, and 1985. And his experience, he became the assistant professor, Disaster Prevention Research Institute, Kyoto University, until 1987, and then the associate professor, Faculty of Engineering, Tottori University, 1987 until 1995, associate professor, Faculty of Agriculture, Kyoto University, 1992. Oh, sorry, 1995 until 20 and 2, and associate professor, Disaster Prevention Research Institute, Kyoto University, until 2005, and currently he is the professor in Disaster Prevention Research Institute, Kyoto University, from 2005. I think there are several publications of Professor Masaharu Fujita, but you can explore independently in the Google Scholar, Scopus, on the other media. And his research topics are about the sediment transport hydraulics, countermeasure and warning system for sediment disaster, and sediment management. Okay, today Professor Masaru Fujita will bring a presentation entitled Development of a Multi-Hazard Simulator for Sediment Disaster and its application for sediment disaster risk management toward future research. And good people, if you have any question regarding this first session, you may directly comment in the Zoom chat box, and I will choose the best question to be answered by the speakers. And please mute your microphone during the presentation. Sensei, are you ready to deliver your presentation?
Yes. Yeah.
Okay. Okay, Sensei, the time is yours and you will have approximately 30 minutes for deliver your presentation to us.
Okay. Thank you very much. I will share my PowerPoint file. Okay. Okay. Can you see?
Yes, we can see your presentation well. Could you please?
Okay.
Yes.
Yeah. Good morning, ladies and gentlemen. And I am Masaharu Fujita. I'm a professor of Disaster Prevention Research Institute of Kyoto University. First of all, thank you very much for giving me this opportunity to give my speech in this international webinar. And actually, so my office is in Kyoto, but today I'm joining this webinar at a hotel in Tokyo. This kind of online system is very convenient for me anytime and anywhere if I can find some small time, so I can join. Okay, anyway, the title of my speech is Development of Multi-Hazard Simulator for Sediment Disasters and its application for sediment disaster risk management, particularly toward future researches. As you know, the Indonesia and also Japan have suffered from sediment disasters. And also we have the sediment disaster mitigation system composed of structural countermeasure and also the non-structural countermeasures. But the number of victims does not decrease. Every year we have a lot of victims by the sediment disasters. So here, so we need to develop new technology, and also we need to have new idea for the sediment disaster mitigation. Here, so just I want to point out the important topic toward future researches on sediment disaster mitigation. That is my point of today's speech. Okay, as a background, what is a future research theme for mitigation for sediment disasters due to heavy rainfall? This is my point of my speech. Okay. Anyway, so you know the to mitigate sediment disaster, we have two kinds of countermeasure. One is structural countermeasures, such as erosion control works and sediment runoff control works and forest conservation works. And also we have the non-structural countermeasures, such as law for sediment disaster mitigation, and also education and hazard maps and warning and evacuation systems. We have this kind of countermeasures. Today, here, anyway, so even if we have this kind of countermeasures, so you know under the climate change, the sediment disaster is getting worse. So we need to develop new technology and a new idea. So today I want to focus on the non-structural countermeasures, particularly hazard map and warning and evacuation system. Just I want to talk about the future topics in this research field. Okay. Anyway, so today I'm talking about sediment disasters due to heavy rainfall. So heavy rainfall condition is very important parameter. So but as a rainfall monitoring now, so the rainfall monitoring data with high precision and high resolution is already available. So look at this figure. In Japan, we have the radar system, and so this is a high resolution. Just one mesh is 50 meter times 50, 500 meter times 500 meter. Very high resolution and high precision. And already we have this kind of very good data of the rainfall. Okay. And also Indonesia and also Japan have the sediment disaster information system. Already the system is working. Is it good or not? I'm not sure, but anyway, we have that system. In Japan, government monitors rainfall conditions, and they predict the sediment disasters, and then government government gives the sediment disaster information for 1 kilometer mesh size. And and also the local government will survey the occurrence of local hazard. Okay, and looking at this information, and they are surveying the local hazard, and then if necessary, city level gives the evacuation order to the resident, and the resident will take evacuation action. This is the system in Japan, but simply I have just questions. Is the sediment disaster information effective for warning and evacuation? This system is effective or not? This is my question. For example, just another question is, can the residents imagine hazards coming soon and the sediment disaster risk? Government give this kind of information. This is a sediment disaster information in Japan. And here, just for the 1 kilometer mesh, we can know the risk of the sediment disasters. There are 4 categories, okay, from yellow to purple. And purple is the highest risk of the sediment disaster. Okay, so looking at this information, everybody can know the risk of the sediment disaster. But they cannot imagine what kind of hazard is coming. Okay, only the risk of sediment disaster is high or low. Okay, that is a current system. So by this information, the residents imagine hazard coming soon and sediment disaster risk. This is a very important question. Okay, anyway, and also this system is based on empirical and statistical analysis. So looking at this figure, and the vertical is 60 minutes precipitation, okay, and the lateral is soil water index. This is something like cumulative precipitation. government monitors rainfall, and maybe we know the condition time by time, and the rainfall condition is going this way. And now we predict the next 1 to 2 hours rainfall condition. Okay, and this is a critical line for the sediment disaster that is based on the empirical and the statistical analysis. Okay, and if the rainfall condition is coming into the high risk region area, local government issues the sediment disaster alert. That's a system, but this is these methods are based on empirical and statistical analysis. Okay, so because not based on the mechanism of hazard, the process of the sediment disaster is not informed. Only risk is high or low. Okay? This is only information on the whether sediment disasters occur or not. Yeah. And also the regarding the hazard map. Hazard map is very basic information for the sediment disaster mitigation. And also the hazard map are mainly based on the topographic data. So in Japan, so local government and sets the yellow zones and the red zone. Yellow zone is areas with risk of sediment disasters. Red zone is areas with high risk of damage to buildings and significant damage to the lives or bodies of residents. Yellow and red zone. This is an example of the hazard map. And this area is yellow zone of, for landslide. This is a landslide prone area. Okay, this is yellow zone for the landslide. And along the river, they set the red zone and the yellow zone for debris flow. Okay, but this is based on the topographic data. So the gradient slope and watershed area and something like this. So they don't consider the behavior of debris flow. Okay, so this is another problem. So just I said there is a sediment disaster, current sediment disaster information effective or not. Okay, here, so what should we study for a future warning system? Okay, so here, so I will take 4 points. Okay, first one is a system able to identify the risk distribution of debris flow on the alluvial fan. I said the here, for example, this area is yellow zone for debris flow. That is based on the topographic data. But actually, even if the debris flow run in this river, the risk is different. Maybe near the river, risk is very high, and maybe damage by the debris flow could be very high. But a little bit far from the river, the damage is very small. Okay, but this is only based on the topographic data. That is all the area is yellow. Okay, yellow or red. But I think we need risk distributions of debris flow. Okay, so maybe if we can say give some risk distributions, maybe a resident can understand my house is dangerous for debris flow, or we may just take care, it's enough or something. So this information is very important. The second is a system able to provide the process of sediment disasters. I said the current information cannot provide the process of the sediment disaster. Maybe resident knows the now risk of the sediment disaster is high, but what kind of hazard is coming? What process happen? Nobody knows. But a system able to provide the process of sediment disaster, a resident can understand the risk. The third is a system able to provide multi-hazard information. During heavy rainfall, many kind of hazard happen. Landslide, debris flow, and flood inundation or something. Maybe this kind of information is very useful. And the last is a system able to accurately indicate the timing and location of evacuation. The timing of evacuation is very important information. So if the system can indicate the timing, it's very nice. Okay. Anyway, current system is based on the empirical and the statistical method, but empirical and the statistical method cannot solve the above problems. So we should take advantage of simulation method in developing the system. That is my point I want to say here. We should use the simulation. Okay, that is my point. Okay, so now we have the simulator for the debris flow and landslide. Okay, but the anyway, almost of participants are not familiar with simulator. Okay, but so here, just I want to point out the future problem in this research. And if you are interested in this thing, I'm very happy if you take some research on this one and this point. Okay. And okay, so firstly, the points of future studies on simulator to solve the problem. First, I want to say increase in the reliability of simulation. Reliability, okay? Even if we develop the simulator for the landslide and debris flow, if the reliability is very low, nobody use, right? And government cannot trust the result. Okay, reliability is very important. So for the increase in the reliability, first, validity of the input data. Input data is very important first. And also use the high resolution rainfall distributed data. As I said, in Japan, we have the radar system and we have high resolution and high precision rainfall. So now we can use the this kind of very good quality of the rainfall. But if you are using the ground rain gauge, maybe it's not enough. Okay, maybe we need the high resolution rainfall distribution. And the next is improving the accuracy of the calculation. Okay, Maybe the researcher try to improve the simulator to get the more good accuracy. Okay, so this is very basic. And next is properly representing the disaster process. Okay. Anyway, disaster process is very important for the sediment disaster mitigation. So simulator can represent properly, accurately the disaster process. This is very important point. And a correct understanding of simulation result. Okay. Anyway, simulator can provide the result. Anyway, the simulator provides the result. But we need to understand this result is reasonable or not. This simulation result is good or not. Okay. Correct understanding of simulation result. This is very important. So for students, participants, I want to say, please study hydraulics. Okay. And last is not only pursuing good accuracy of simulation, but also pursuing whether simulation result can lead to a good warning evacuation. Anyway, researcher try to pursue the good accuracy of simulation. Okay, we try to, but important thing is the whether simulation result can lead a good warning and evacuation. Okay, even if the accuracy is not so good, but if the simulation result can lead to a good warning evacuation, this system is very nice, I think. Next is make the simulation process easier. I said almost all participants are not familiar with simulation method, but if the simulation process method is easier, much easier, everybody can utilize this simulator. It's very important. An easier method to create topographic data. Okay, this is very important. The topic and the development of graphic user interface. Okay, if we have the graphic user interface, many people can utilize the simulator. Okay, and the appropriate method of parameter setting. Okay, in simulator has many parameters, but first we have some problem on setting the parameters. Okay, appropriate method is necessary. And the next is wide application of simulation. Okay, and so maybe we can apply the simulation result to the real-time hazard map for appropriate evacuation action. Okay, and also we can apply the simulator to evaluate the effectiveness of structural countermeasure, like check dam, channel work, or something. Okay, I pointed out some important points in the future research. Now, the next, so just I want to introduce the performance of existing simulator. Okay. How far can the existing simulator be applied to warning evacuation systems? Just I want to introduce. And as a risk distribution of sediment disaster in local areas, I want to introduce debris flow simulator developed by Takebayashi. That name is More42DH in IRIC system. This is a free software everybody can use. Dr. Takebayashi is my colleague in my laboratory. Okay? And as a sequential multi-hazard process in basins, I want to introduce SIM-HIS developed by Dr. Yamanoi and me. That is storm-induced multi-hazard information simulator. First, just I want to introduce the Morph2DH by Dr. Takebayashi, this IREC software. If you are interested in this system, please explore the IREC. Maybe you can find the website easily, okay? And this Morph2DH is simulator for debris flow, and they can consider the houses, okay? They can set up houses. Okay, and debris flow is coming upstream. This is a simulation result with houses. This is a simulation result without houses. Please compare between these two results. This one is this debris flow affected by the houses. There are no houses. Debris flow is deposited like this. Okay, but actually the debris flow is affected by the houses. The deposition area and the damaged area is very narrow comparing this one. Okay, so this simulator can give this kind of result, and maybe this is very useful information for the warning and evacuation. Next is just this is origin of the debris flow, and the debris flow is developing and attack this area. Okay, this origin, the volume of the sediment is around 2 to 3,000 cubic meter, but this debris flow erodes the material, wet material. Okay, and then this debris flow developed to the up to 34,000 cubic meter, around 10 times of the original volume. Okay, and so they can this simulator can provide the velocity of the debris flow and time from the origin to the this area. Very useful. And how to use this simulator? I explained the hazard map in Japan. This is the same area, okay? And this is the yellow zone for debris flow, and this is the red zone for debris flow, based on the topographic data, okay? Actually, I showed the debris flow is attacked very narrow area, okay? Something like this, okay, narrow area. But on the hazard map is, this is based on the topographic data. So this area is a high risk area for debris flow. But actually debris flow is attack around this area, okay? So for, if we use this simulator, anyway, so debris flow simulation under the condition of possible sediment volumes, and analysis of flow velocity, flow depth, and sediment deposition, and distribution of risk level of sediment disaster due to debris flow. So maybe along this river, risk is very high, but around here is risk is not so high. Okay. So this information can use for the emergency refuge place and the evacuation routes and the safer place in the yellow zone. So maybe very useful. And also the now pandemic situation, all the people evacuate only one place. That refuged area could be very crowded. Okay, and in the considering pandemic, COVID-19, so it's not so good conditions. Okay, many people are coming all together. But if you use your simulation, the resident in this area need to evacuate more safer place. But the people living here, maybe they can stay in the upstairs, second stair or third stair, something. So don't need the evacuate to the refuge area, something. And finally, just I want to introduce multi-hazard simulator developed by Dr. Yamada. Okay, and this system is using this kind of channel network and slope, channel network and unit slope. And so using this simulator composed of many sub-models, landslide model, and the sediment production model, and the sediment supply model, rainfall, and the sediment runoff model. So using this simulator, we can identify the location and the time of landslide. Okay, and also the this sediment is transported to the downstream, and in some case, the bed degradation take place and causing the inundation. Okay, so we can simulate this kind of simulation. Just I want to show you some example of the simulation. Okay, this is a channel network. Okay, just channel network, and maybe you can see the slope. Okay, just this unit slope is divided in the slope unit. We simulate the landslide for each unit slope unit like this. Anyway, so just I want to show you the result of the performance of this simulator, and just this is a river basin, and please look. Maybe you can look at the rainfall condition from 0 to 150 millimeter per hour, rainfall intensity. Okay, white to black. That is increase. Maybe you can see the change. And on this map, I showed the risk level of the landslide and the flood inundation. Okay, for example, the risk of the landslide in this slope is high. The color will be changed, green to red. Okay, and also this green is safer, and if the risk of the inundation is high, getting high, the color is changed, green, yellow, red. Green, yellow, red, and purple. Okay, and 4 categories. Okay, now I want to show you the result. The actual the simulation of the actual sediment disasters. Rainfall is starting. Okay, now it's not so around 10 millimeter per hour. So now the rain intensity is around 15. Some slope has a risk of the landslide. but yellow. Okay. Now, okay, around here is the risk of the landslide is red. That is third level. But there are no inundations, the river. Sorry. Here is some river in the some rivers. This part, maybe we have some inundation, flood inundation. Okay, something. Like this, we can know the change of the risk of the landslide and the flood inundations. This we call this simulator is multi-hazard simulator, like this. Okay, using this simulator, we can find the timing for evacuation. For example, this Otoishi region, district. Okay, this is the risk level of the landslide. Okay, low level is high level, and this is a flood risk level. Local government issues the sediment disaster information here. Around the people have the 2 hours for evacuation because around here risk level is increasing quickly. Okay, so they have the 2 hours for evacuation. Something like this, we can provide the timing of the evacuation. Okay, finally, just I want to summarize my talk. And simulators of debris flows and landslide should be more used in developing the sediment disaster warning and evacuation system. Okay, so I want to say, please improve the simulator and please develop the new simulator. So just I want to say this first. And next is, it is important to improve the reliability of the simulate reliability. And we need to cultivate our ability to understand correctly simulation result. This is very important issue. Maybe basically we need some good knowledge in the hydraulics and the sediment transport hydraulics and soil mechanics and something. Okay? And we try to pursue the accuracy of the simulation result, but it is much more important that we should pursue whether simulation result can lead to a good warning evacuation. Yeah. And the support system to create input data, such as topographic data, is necessary. If we have this system, many people can utilize the simulator. Okay, terima kasih, and thank you very much. This is my the end of my presentation. Thank you very much.
Thank you very much. Okay, thank you, Sensei, for your amazing presentation. Ladies and gentlemen, please stand by, hold on your question because we will continue directly to the second speaker first.
Yeah.
So yeah, okay. For the next speaker, we have Mr. James Sulfan. Mr. James, are you already there?
Yes, I'm here. I'm ready.
Okay. Okay. Firstly, I will read the short curriculum vitae of Mr. James Sulfan.
Yes, please.
Okay. Mr. James Zulfan got his bachelor degree in civil engineering in 2004 in Institut Teknologi Bandung, and he continued his education for Master of Science in Hydraulic Engineering and River Basin Development, and graduated in 2017 in Delft Institute for Water Education. His current position today, he is a researcher in Directorate of Technical Development for Water Resources, Ministry of Public Works and Housing. Okay, for his publication, I think there are several publications that you can see also in Google Scholar, Scopus, and the other media, and I will maybe mention two of them. In 2020, he published about improved vegetation floodplain rawness for one-dimensional hydraulics models, and in the previous years, he published about modular check dam towards water infrastructure. And his certification, he got a patent in 2018 about the method of implementation of cube concrete blocks hexapod to reduce local scoring and river bed degradation. Okay, I think that's all about the short introduction of Mr. James Sulfan. So, ladies and gentlemen, I will not tell everything about his material, so I will let Mr. James start his presentation. Mr. James, you have approximately 30 minutes or 45, it's okay, to deliver your presentation. Ladies and gentlemen, please welcome Mr. James Sulfan.
Yeah, thank you. Let me share my screen first. Okay. Yeah. So can you see my screen?
Yes, we
Okay.
can see it clearly.
Yeah. Okay, thank you for your kind introductions, Pak Rian. Yeah, selamat pagi, good morning, everyone. Also, I want to greet Pak Agus Mariono and also Fujita Sensei for being with us today. So, yeah, I'm delighted to be invited in this webinar. So I just want to share maybe some of my experience and projects about the sustainable infrastructures that might be relevant for this topic. Okay, so yeah, I title my presentations called Water Infrastructures in Indonesia, Challenges and Future Trends. And I will start from the current state of the water infrastructures in Indonesia, and then followed by what are the challenges in the hydraulic structure projects, and in the implementation of tech innovations. And I will close by mentioning the future trends on water resources projects. So just a brief picture just to show you about the condition of the potential water resources in Indonesia. So as you can see here in this picture, you can see lots of different colors that are showing us about different condition of the water surface in Indonesia throughout the whole islands in Indonesia. So we have the red one, which meaning is the deficit conditions for water surface, and we have a green one for the surplus condition. So interestingly, is the obviously the red one, the red color is only placed on the area which have lots of citizens or people in it. So due to the high demand of the water, the water surface area kind of deficits. So what are our strategies for this? We need to, there's a lot of strategies or measures. One of them is we can maybe storing a lot more water in the rainy seasons to be used in the dry seasons. And yeah, this is one of my also favorite pictures that's showing our infrastructures in the whole river basin system. So from the upstream to the downstream, we have sediment lahar debris protections, kind of sabo dam or check dams. We also have installed structure for raw waters, which are intake, distribution pipe, water treatment plant. And we also have kind of structure to be used for detention basin and flood control, such as embung or polder. Also for hydropower, like dams, spillway, and for irrigation purpose, we have a weir, sand trap, irrigation channel. And last but not least is the coastal protection use, like a jetty or coastal dikes and so on. So I will not explain all of them. I will just focus on dam and weir structures. So if we, this is a nice picture of Jati Gede dams that are already be operated in the West Java. So do you know how many dams do we have in Indonesia currently? So based on the data from the dams central in the Ministry of Public Works, we called it Pusben, the number of the dams in Indonesia is growing rapidly. We are now arrived in the value of 245 dams in total that are already being built. And we are now still in ongoing projects to build around 45 more dams. So in the end of 2024, we are hoping to increase our capacity of water storing in Indonesia from around 13 billion meter cubic into around 16 billion meter cubics. And we move to other structures that are also used for storing the water. We have embung. We call it embung, kind of an artificial reservoir in the dry area. So we have embung around 1,212 units spread in all over Indonesia. And maybe this is one of kind of structure that we are usually see in our daily life. We can find weirs everywhere. So it's about 1,500 in total registered structure in Indonesia. So it is also being used for flood control sometimes. Also, the main purpose is for the irrigation supply and for raw water distributions. So this is a kind of structure that are being used and installed in order to storing more water, so we can have more equal distributions in whole area of Indonesia. Now, if we take a little closer look into the weather conditions, so we classify as 4 different conditions if we want to monitor the physical conditions of the weather. So first, we have a good conditions, which means that the structure is fine and the function is still works well. And second one is we have a light damage classifications, which meaning that maybe there are some cracks, or maybe there's some light or a slight structural failure, like maybe there's a small cracks, or maybe there are vegetated occur in the structures, but still it doesn't interfere with the main function of that wear. We also have a medium damage classification, which meaning that there are some structural failures, but then it still doesn't interfere with the main purpose of taking water into the intake. And the last one is the heavy damage condition. It's meaning that the main part or the main structure are being collapsed, so that the main function to take water from the river into the intake cannot be done. So in 2017, I tried to summarize the condition of wear in Indonesia, that we start from the light damage. They are more or less 13%, but then the condition, one of the example is like a cheaper wear. And then we also have 17% medium damage. For example, is the collapse of the dike in the right side, but then you still have the intake in the left side, so then it doesn't interfere of the function of the wear, still works well. And the last one is the heavy damage condition. It's meaning that some segment of the crest of the wear is being collapsed. It's meaning that the water in the river cannot be raised enough so that the water can came into the intake. So it's not work the intake functions. And we have more than 50% wear structure that are in the good condition. It's meaning their structure is still good and the function still works well. So this is just to show you what kind of phenomena of the hydraulic structures with lots of reasons. There are lots of reasons to be conducted. So I try to compile and summarize some of the reasons, and I call it as a challenge for the hydraulic structures. First, it might be some kind of misunderstood, or there are some kind of miss in providing a proper design and technology for that particular area. Also, there might be happen because of the extreme weather. Maybe we design, maybe we under design the discharge of the wear or the structure comparing to its real conditions. Also, they are because of aged structures. If you can see from the pictures, we can see that there are some weirs that already built in 1931. And there are also some because of the illegal sand mining, which will directly impact the river morphologies, so that the scoring rate will be higher, which can also interfere the stability of the weir structures. Also, we have kind of problem with the shortage of the raw materials. For example, for dam construction, type of embankment dam, we need lots of earth material, natural material to be used for the core. And the last one is lack of maintenance and monitoring. After we build the structure, we also want to have a periodic and a nice maintenance and monitoring to have condition to maintain and preserve the conditions. So yeah, this is just to show you the challenges that we are facing in hydraulic structure projects. And yeah, this year we also receive additional challenges. As you know, that we also facing the COVID-19 pandemic. So of course, this is also become a huge impact for our ministry, because currently we are conducting many construction projects in all over Indonesia, and this COVID-19 for sure hit us badly, because some of the projects obviously needs or includes more lots of people and also workers in the same place in the same time, which will increase the risk of being contaminated. So I will just show you there are two measures that our ministry has taken. First, we launched the Cash for Work program. So this is aimed for the local people that are suffered the most because of the COVID-19 pandemic. Lots of people lost their jobs, and yeah, the decreasing of the economic growth. So in this case of Cash for Work programs, basically we hire the local people to help us rebuild or conducting low-scale projects in their place. For example, maybe rehabilitating the lining irrigations and so on. Also, for the large project like a dam projects, we implementing the health protocol so that we can still continuing our projects in line with the health protocol. Now back to the our topic. What is the strategy for more sustainable construction? So if I allow to mention that there are at least two specific key factor of sustainable construction infrastructure, I mean. So the first one is time and second one is cost. We want to have a faster construction with a lower cost, right? Everyone wants that. But then nowadays we also demanded to have the third factor, which is the environmentally friendly factor. So how do we cope these factors, these constraints to our construction projects? There are several measures that our ministry have taken, but I will just explain two measures that are relevant with our topic today. The first one is we try to implement the modular constructions. And the second one, we also finding a new alternative of material for construction that are, we hope can be more sustained in the terms of the environment. So what is exactly the modular construction? So this is not a new technology. It's already being used in Indonesia, for example. It's already being used in bridge engineering constructions, also in the housing and building constructions. So now we want to also implement and adapt this technique into the water resources constructions. So we try to build and design a precast concrete that can be used for constructing water resource infrastructures. And this has given us several benefits. First, it's easy to build. Second, is faster construction, for sure, because basically you just order the specific precast concrete from the factory, and then you transport it into the site, and you can just install it on site. Therefore, it will be less waste because you are using less formworks, you are using less material, you are using less worker. So we're developing some of structures in terms of water resources, hydraulic structures. So we start from the research inside the laboratory, and then we go through several trial and error in the fields, and we have finally have the final design. But still, with there are some limitations, but we are still improving and developing it. We also already registered it as a patent of the technology. So, for example, we have a river revetment groin that are also used with the precast concrete. They are lightweight concrete, so it can be done by manual. Also, an irrigation lining. Also for the Cybodan constructions. And last one is the four-weir construction. So this is not a rocket science. So we start from the model in the laboratory, and then we also adapt the technology that are already being developed in other countries, and we try to implement in our in Indonesian conditions, which are also be specific and kind of unique, different from other maybe other countries' locations. And the second one, this is the second measure that I just want to show you that more than 50% or most of dams in Indonesia are being designed by the embankment or earth dam. Therefore, we need lots of material, of the natural material to filling the dam, the crest. So sometimes there are some problems because the availability of the material is different one place to another. So sometimes we have to import the material from other location, even from other islands, which will be automatically increase and escalate the project cost significantly. So we need to find more other alternative, so we can reduce the needs or the requirement of the earth material, because the earth or the embankment material they are usually used is taken from the mountain or from the hill or from the valley. So we want to reduce that and use other options. So what are other options? First, we have the concrete cement gravel dam that it is also already being developed. I know one of them also already being installed in Japan. So we use the CSG, it stands for the concrete stand gravel. It's a mix of concrete with the material in the river surrounding. So we don't need to take to dig any mountain or hills. So we just take the material from that particular river and then mix it with the concrete. Then we call it the CSG. And then later, after we install it with this kind of design in the pictures, yeah, we're lining it with the high quality of concrete. And this is already being approved in other countries for dams, but in Indonesia, we already built with the CSG is for the Sabo Dam with the height more or less 15 meters. But for them, we haven't conducted yet. And the other option is if we don't have also the material in the rivers, we can also use the asphalt core. This is also haven't been done in Indonesia, but the use of these two kind of method and techniques can reduce the needs or the requirement of the natural material from the mountain. We can say that. Now, so we back to the questions. What is the future trends for water infrastructures, especially after the pandemics? So yeah, if I can mention, there are at least 3 topics that will be, in my opinion, it will be growing more intense in the coming years and in the futures. First is the digital-based constructions. Second one is the robotic-based constructions. And third one is the digital-based monitoring. So what are the digital-based constructions? Maybe this is one of the perfect example of the digital-based constructions, which are building information modeling, or BIM. I guess everyone here is already familiar with these terms, the BIM. So by using this system, all the stakeholders of the construction or the infrastructures can start to design, construction, and then evaluate, inspect, and even monitor and maintenance from a remote area, because all of the system can be used using cloud, you can say, or using online. And yeah, we are moving from the analog or the manual drafting into the digital drafting, and we now integrate it with more sophisticated technologies using an apps or smart gadgets that will produce an as-built drawing which are more details that we can use for simulate the CFD numerical modeling to see the performance of the structures in the design phase, or even in the maintenance phase after we build it. So we also, this is also one of my favorite topics about the hybrid models, because we integrate the numerical modeling with the physical modeling in the lab. So I also encourage young engineers and students to yeah, try to see and to learn the CFDs and maybe some of language programming for the numerical analysis, which is now is open. You can learn it from YouTube or so on. Yeah, and this is just an implementation of a BIM in dam and water research projects, in the large-scale projects. So what else? We also already seen the 3D printing for construction, right? But then you may say that, okay, 3D printing is for a small scale. 3D printing is using in the labs. But see how the Tsinghua University built their bridge on site using the portable 3D printing. So imagine if this kind of technology can be integrated to be used in maybe starting from scale of water infrastructures. I would love to see our modular technology combined with this kind of technology. Yeah, now about the digital-based monitoring. We also want to adapt the technologies. We want to move from the conventional monitoring of the, we can say, the irrigation system from the upstream, from the main wares into the distribution, in fact, into its organizations. So we develop a kind of online system to reporting the conditions and taking kind of data instrument from the fields. So we can gather in the data centers, and then we can evaluate and give feedbacks to the sites directly. So the same story with the dam. This is also our dream, that to have a dam safety monitoring system which can be integrated from all of our dams instruments that are already being installed into one big data center to evaluate the stability and the safety of the dams. So yeah, in the end, I just want to show, so this is our main purpose, or our kind of final goals, that we want to have a smart system for the entire system, structural, hydraulic structure system in entire river basins that can be used and integrate all the data, all the operational and maintenance to be used and to manage properly, so we can have a better water quality and water quantity for the community. Yeah, just to sum up my presentation, I just want to mention that the sustainable constructions will require more efforts, more time, more costs from all the stakeholders at the beginning. But once we are settled, bigger outcomes will occur because we are already familiar. It's already being our habit for the sustainable constructions. So let's make all of the challenges mentioned before as an opportunity, not just to become an obstacles. So yeah, finally, a synergy to build an integrated sustainable infrastructure is very essential for all stakeholders, not only a government, not only the contractors, the consultant, but also maybe the academicians and all the people inside the territory. So yeah, I want to end my presentation here, and I want to back to moderator, Pak Rian, please. Thank you for listening.
Okay, thank you, Mr. James Sullivan, for the interesting presentation. Okay, ladies and gentlemen, I think we will enter to the question and answer session in this first session of this international webinar. I have read several questions for Professor Masaharu Fujita and Mr. James Sulfan. So maybe I will read maybe one question and then will be directly answered by the speaker. Okay, firstly, I would like to read a question for Professor Masaharu Fujita. Wait.
Just I have three questions.
Okay, I
Three
will
questions.
read. Yeah, I will read it for you.
No, I already checked.
Oh yes.
Yeah. And first question is from Tessa Putri.
Yes.
Okay.
Yes, sir.
Yeah. Just now I will reply for this question.
Yes, I have ever read your research about sediment disaster in Indonesia. What's the differences or similarities of sediment disaster in both Japan and Indonesia? For example, the mitigation or other things.
Okay. Actually, just I will say the characteristics of sediment disaster is very similar between the Indonesia and Japan. Right. And so there are many factors, but they are in Indonesia, volcanic eruption, and also the earthquakes and heavy rainfall. These are the main causes of the sediment disaster. In Japan, also we have the same factors in the sediment disasters, but maybe the feature of the rainfall, heavy rainfall, is a little bit different between the Japan and Indonesia. I think in Indonesia, heavy rainfall is very local and very strong and a very short time. But I'm not sure the current situation. But in Japan, these 5 years we have a very heavy rainfall, and also the that heavy rainfall is very strong and very long. Strong and long. I think the Indonesia is very strong, but not so long and short. For example, this year we have the heavy rainfall in Kyushu Island. Just to peak rainfall intensity is around 100 millimeter per hour, and cumulative rainfall precipitation is around 800 millimeter or something. In 2017, just 3 years ago, we have also the similar rainfall. Rainfall intensity is around 100 millimeter per hour, and the cumulative precipitation is up to 800 or 1000, something like that. So as a result, we have the very severe flood inundations and also the sediment disasters. That is a combined disasters. That is a characteristics of recent sediment disasters. Yeah, and so in the mountain side, many landslide and debris flow took place continuously and simultaneously. Okay, as a result, a large amount of sediment was produced. Okay, much sediment was produced, and as I said, cumulative precipitation is very large. So that means the flood discharge is very large. Okay? So as a result, almost of the produced sediment by landslide will be transported to the downstream. And bed degradation, severe bed degradation took place, and causes the very huge flood inundation, and also sediment also the inundated. That is just the characteristics of recent sediment disasters. I think this is a change, but basically the situation is very similar between Indonesia and Japan. Yeah. Okay.
Okay. Thank you, Sensei, for the answer.
Uh-huh.
I have another question from the participant. I will read it for you. The question is come from University of Catholic Widya Mandira Kupang. I believe that natural risk management could be anticipated effectively if we have not only good information, but also we can know about the factors that cause the risk, its triggering variables, as well as their explaining variables. So could you please explain or share your good experience about it, Sensei?
Okay. Maybe for example, for the landslide occurrence, the groundwater level is most important factor. Ground level in the slope is most important factor. And if we can monitor the groundwater level, maybe we can know the risk of the landslide or something. But my point is just even if we know the risk, that information is the landslide occurs or not. Something like on off. So the how is the affected area and the scale of the landslide, maybe we cannot understand. Okay, but when we consider the evacuation, the scale of the hazard is very important factor, and also the affected area is also very important factor to take a better evacuation. Okay. Sometimes we have a big problem, and is like this. During heavy rainfall, people will try to evacuate, and but on the way to the refuge area, they meet the debris flow. If he stay in house, they don't lose his life. Okay, but he tried to evacuate to the refuge area, so he attacked debris flow attacked him. Something like this. So generally, also in Japan, local government try to all the people try to evacuate all the people in the high risk area. Okay, but in my opinion, the sediment disaster is very local phenomena. Generally, very local area. So maybe you must evacuate quickly, but you don't need evacuate. Maybe there is some risk distribution. So my point is that, so anyway, for his or her question, we have some factor to predict the phenomena like the groundwater level. But even if we know that, maybe we can know the hazard happen or not. But we need much more information. Thank you very much.
Okay. Okay. Thank you for your response, Sensei. I think we still have two questions for you, Sensei, but I will move to the Mr. James Sulfan first. Is it okay?
Sorry.
Okay. Okay. We still have two more questions for you. Mr. James, I think I will start the next question for you. Wait, I will read it for you. Okay. So actually, Professor Fujita and Mr. James, in the end of your presentation, recommend that future trend in civil engineering field would be simulator, digital-based construction, building information modeling, and extra that is digital-based, like that. Mr. James, how can we, as future engineers, prepare toward these challenges?
Yeah, I mean, yeah, thank you for the questions. Yeah, for the young engineers, so like I said, mentioned before, uh, it is essential to know like the tools like for modeling software, but also don't forget that we also need to understand the fundamental theory inside of the modeling. So it is good to learn the modeling softwares and maybe programming language because it will make our life easier as an engineers.
Yes.
But also we need to know exactly the technical fundamental maybe theory inside of the modeling. So like Fujita Sensei mentioned that you need to learn the hydraulic and hydrology, the theorem understand before you understand or before you learn the modeling software or something. Yeah.
Okay, thank you, Mr. Jim, for your response. For the next question, I think I will ask to you again about the question from the participants. Okay, this question comes from the head of our study program in Civil Engineering Department, Mr. Iman Haryanto. Thanks for Mr. James Zulfan for valuable information delivered through the presentation. My question is, does the Ministry of Public Works and Housing opens the access for students to participate in research or project works managed by the ministry, especially regarding with recovery work for the pandemic, operation and maintenance water infrastructure buildings, either remote or on-site method, development of strategic, sustainable or futuristic infrastructure like modular structure, new alternative materials, digital construction, robotic base, and digital operation and maintenance. Many thanks.
Yeah, thank you for the questions again. Yeah, of course, yeah, I mean, as the minister said that our project sites in the whole Indonesia territory is just consider it as an open laboratory. So, in fact, UGM is also our partner with the ministry. We are also now conducting a master degree for our employee, like the super specialist master programs, which are also being held. One of them in UGM. So basically, you can just yeah, we can start to discussing it. We have kind of what you call the system to connect with the academici to maybe making a research project together or a project collaborations. It is also possible. So we in the Ministry of Public Works is really open, especially to develop more and more an efficient and valuable development in the hydraulic structures, infrastructures. Yeah.
Say, I have not that answer. Thank you for your response, Mr. James. Okay, I think I will come back to Professor Masaru Fujita for the last two questions for you, Sensei.
Yeah, yes.
Okay, the questions come from Kevin from Catholic University of St. Thomas. What parts of the simulator are you working on that will be improved in the future, and whether the methods used in the simulator can or have been applied in other regions or countries, given that a country like Indonesia doesn't yet have adequate supporting technology in many areas prone to sediment disaster in the form of landslide or debris flows?
Okay. So I and also the Dr. Takebayashi and Dr. Yamanoi are my colleagues, and we are developing the simulator. And basically, we try to develop the source code of the simulator, source code. Okay, and now we are improving that source code for the simulation. And in my presentation, reliability is very important. Yeah. So just I show the some result of the simulation, and if the government don't trust the simulation result, they might use this one. And also the our uh, our working in our we are try to improve the source code for the simulation. That is our task. And also the we try to utilize this simulator to the disaster mitigation. Okay, simulator is just academic research. Yeah. But final, our target is to utilize this simulator to the actual mitigations action in the local government or government. Okay. So
Okay.
now just to SimHIS, that is a multi-hazard simulator. Just some people are interested in this simulator, and so now we try to use this simulation result to the local sediment disaster planning, sediment disaster mitigation planning for local area. And but in so we want to use the real-time hazard map. But for me, so we are thinking we have some problem in the accuracy of the simulator. Okay, but now we try to use the simulation result for education for the local people, local community. Okay, and during this kind of heavy rainfall in your region, this kind of hazard will happen. Okay, that is a very nice information for education. Okay, and also now we are trying to use the more for 2DH to identify the risk distribution of debris flow. But also this one is your house is safer than your his house. Something we can say this kind of information, but local government is thinking if this is wrong information, government will take responsibility for something.
Yes.
Yeah. Okay. So this is very critical problem. So in my talk, reliability is very important, I think. Yes, that is current. And also I want to utilize the simulator to Indonesia education. And if you are very interested in the simulator, always we can support you. Okay.
Okay. Okay. Thank you,
Yeah,
Sensei.
thank you very
So,
much.
for student who want to use the simulator, uh, Professor Master Bujita's laboratory could support it, right, Sensei?
Yeah.
Yeah. Okay. Okay, Sensei. We move to the last question for you. Okay. Thank you for Professor Fujita. It is very interesting and fit to research needs in the future. My question is regarded with common situation at many rivers around Merapi volcano. Do you ever visited Merapi volcano, Sensei?
Yeah. Yeah.
Yeah, okay. That very risk to sediment disaster. So do you allow if carry out the collaboration research on sediment disaster at that location? Such kind of research may be supported by multidisciplines in this vocational college University Gajah Mada. maybe the laboratories, lecturers, or students from many engineering technology fields. For example, civil engineering, electrical informatics, or remote sensing technology, maybe something like that.
Mm. Mm. Yes. So just you know we are doing some research for the Mount Murapi area, and
Okay.
we know the almost tributaries, and just we are very familiar with the situation in the Mount Murapi area. And just I want to collaborate with your vocational school in future.
Yes.
And my
Okay.
colleagues, Yamanoi-san and Takebe-san, also thinking about this. Yeah, just I want to do that. Yeah.
Okay. Thank you, Sensei, for the response. So I think it's positive feedback for this question, right? So we could do any collaboration research in the future in this certain field.
Yeah. Yeah. Yeah.
Okay. Okay. Next, I will move again to Mr. James for some question for you. I will read. Okay, this is a question from Don, University of Catholic Widya Mandira. It is a bit surprising that Timor Island has been categorized to be surplus water resources zone map. How could it be, since we all know that the island of Timor and other similar small island surrounding it was well known to be dry islands? Could you please confirm about that case?
Okay, thank you for the questions.
Okay.
Yes, the map that I showing you before in my presentations is a map that developed by our ministry under the what you call the division of the hydrological and water management divisions. So the key parameter in building that maps is first is the hydrological conditions. It's the parameter of the rain seasons and everything. And also we have another parameter which are also related is the number of the citizen or the people inside the territory. And the third one is the demand in the territory. The demand can also be breakdown into several, which is the domestic demand, also for the commercial demands for the water in these terms. So when we compile it all of the key factors, it's showing that you can namely that most of the main islands that are having lots of industrial and lots of people in it will have more deficit than other places which have less, you can say, citizens and less industrial purposes, things like that. Yeah.
Okay. For the next question, I think it comes from Mr. Bari from Universitas Brawijaya. I think I'm interested in the monitoring of the irrigation system that was previously presented by Mr. James Zulfan about epoxy. What are the projections for the future development of the system, and what are the strategies for improving epoxy services in the future? Yes, it's about epoxy.
Yeah. So currently we have two kinds of systems that are currently built. First one is the epoxy, and second one is the SMOPI. It's more or less the same, but the SMOPI is more into the organizations and the readiness of the whole stakeholders. But then the epoxy is more into the physical conditions to be reported. So in the future trends, we want to integrate the two systems, so it will not confuse the users, because the users are the site officers or the people who are, you can say, like the penjaga pintu, the guard of the gate of the wares on sites, that we want to utilize them also by giving them some knowledge about using some digital gadget to be reported daily, monthly, yearly about the condition of the dam, irrigation channel, and everything. So this is a big purpose is the modernization of the irrigations. So we want, so right now, currently we still making the baseline. Baseline meaning that we are still developing the system. There are some bugs, there are some limitations, but yeah, I mean, there are always be a first time for everything, right? So we are still improving it. So maybe later with just one system, because right now we have two systems, one system we can integrate them and making the modernization for irrigations.
Okay, yes, I think epoxy is very useful for our future engineers in the future. So when I first try about the application, I think it is good because I think in the future our students will have like digital thing to do survey monitoring and others like that. Yeah. Okay. There are still two more questions for you, Mr. James. I will
Yes,
read it
please.
now. Okay. From Universitas Musirawas, Sumatera Selatan, South Sumatra. So how is the development carried out to make the dam in hilly areas and the obstacles experienced in the construction of the dam in hilly areas?
Okay, thank you. In hilly area, which mean it's still in the upstream area, right? So
Yes.
the obstacle or the problem that we are facing mostly is to finding the right positions, like the right locations, because building a dam doesn't mean that you just construct it where you can have the most optimum inundations of waters, but you also needs to consider the geological aspect, because you want to have a nice, a good, a strong foundations below your structures. So sometimes the ideal locations doesn't have a good foundations. Then there are two options: we move, or we treat with we give lots of treatment, which also will cause your project, right? You can by engineering you can protect and you can increase the stability of your foundation actually, but still there are the problem first that we face is finding the right positions based on the geological aspect, and the other one is what are the types? Sometimes you want to find reasonable types of dams. Like, for example, in hill area, yes, you can build a concrete dams, or it is also possible if you want to have an embankment dam. So this kind of choice should be made in order to have an efficiency in terms of cost and also the time limit that you want to address.
Yes, I think also that building earth embankment dam brings multidisciplinary field like geotechnical, hydrology, and others. Okay, okay, Mr. Jim, I think I will give you the last question for this
Yes.
session. Okay, I'm very interested in modular construction. Is there any instruction or guidance to design modular dam to replace earth embankment dam? Is there any
Yeah.
guidelines? Yeah.
Okay. Yeah. So we are like I mentioned before that the modular technology that we develop start from our laboratory projects, but then now it's already being trial on the sites, and this year we are still this year we registered as a patent, but we are also it is an open patent, so everyone can use it later. And we are now still compiling, and we are still designing Indonesian code, national code for the designing and constructing the modular technologies. So we call it SNE, right? So we are now still preparing the SNE, and hopefully maybe the fastest is maybe next year it will be published so everyone can see what is the modular structure for water infrastructure actually. And I just want to add one more additions that Fujita Sensei, I also already try one of your software, the IRIC softwares. I know it for because in 2018 there are an IAHR conference in Jogja, right? So and there are some representative from Hokkaido also, and yeah, we discussed and I just tried the IRIC. I tried for the river morphodynamic, and it is really convenient and really nice software. It's an open software, so I suggest that everyone, if who wants to try a new, for me it's kind of new software, you can just search it, Google it, just download it and learn it. There are also some tutorials in the YouTube, so it's easy to use.
Yeah.
Yes, okay. Thank you, Mr. James. We will wait for the SNA for the modular construction. And I
Yes.
think I will invite our students all over Indonesia to try the software as well. So, okay, I think our question and answer session has finished. So we are very sorry because we could not accommodate all of the question, but don't worry, we still have one more session and you can ask there. Thank you so much for Sensei, Professor Masaru Fujita for joining us. After this, if you still have other activities, you could leave the webinar and hopefully we could meet in the near future. So please give virtual applause to Professor Masaru Fujita. So does Mr. James, thank you for having us in your weekend time, but it is our pleasure that we have you too in our international webinar. And I give you the freedom whether you would like to stay or leave for other activities. Thank you so much. And please give virtual applause to Mr. James Zulfan.
Thank you.
Okay.
Thank you guys. Terima kasih.
Ya,
Terima kasih.
thank you. Terima kasih Sensei dan Pak James. Thank you guys for joining us in this first session with amazing speakers and incredible presentation. We conducted interactive question and answer, but unfortunately we reached our end of the session. But hold on, so we still have one more session with other amazing invited speakers. So don't go anywhere, and I will end my session here. Thank you for joining me during the first session, and I will return the stage time to the master of ceremony for Ahmad and Shahla. Please continue the agenda.
Thank you, Mr. Rian Mantasa, for becoming our moderator in our first session. It's really interesting. Oh yeah, first of all, I want to give a big thank you to our speakers, Mr. James Zulfan and also Professor Masaharu Jita. Thank you very much. And it's really interesting, the presentation from the both speaker. Maybe I should learn and study again from the topic. And it's been a great opportunity to see you and to have this conference here. And maybe Lala, Shahla, what do you think about the first session?
I really like it, Hakim. The presentation from both speakers are really interesting, and I think we can't find it anywhere except on this webinar because we invite people who really are the experts in the civil engineering fields. And I'm very grateful to be here as an MC and get the opportunity to hear and learn from all of these amazing speakers.
Yep.
And I also want to say to all of you who have participated in this room to always put a mask anywhere, anytime. When you go out, keep following the health procedure. Stay healthy, stay safe, because in this pandemic era, we must stay at home doing social distancing. And that's why we can't launch this conference by face-to-face, unfortunately. But here we are doing this conference from home by Zoom.
Yep.
And that's all I think, Hakim, from me.
Okay, thank you, Lala. And we are now continuing our conference to the next agenda. In the second session, we'll hear two keynote speech. The first one will be delivered by Professor Jin Bin Yang, Graduate Institute of Construction Engineering and Management from National Central University, Taiwan, and also Mr. Arya Muhammad, Doctor of Philosophy, Honorary Research Associate from Department of Civil Engineering, University of Bristol, UK.
The keynote speech will be moderated by Mrs. Rizky Citra Islami, Master of Science, which also will direct the next agenda. Mrs. Rizky Citra Islami is a lecturer in Civil Engineering Department, Vocational College, Universitas Gajah Mada, and she teaches about structure and construction management. For her education background, she has got her bachelor degree of Urban and Regional Planning Engineering in Brawijaya University and graduated in 2013. And then she continued her study for her double degree program at National Central University Taiwan and Brawijaya University, graduated in 2015. She has several work experiences in her pastime, such as urban planning consultant, planner assistant, surveyor, freelance consultant, teachers, volunteers, and her current position as a lecturer at Civil Engineering Department from 2016 until now. She has several research in her expertise, and the latest research that she conducting now are integrating social sustainability concept and infrastructure development at pre-construction stage from 2016 until now, and framing database of billboard construction based on geographic information. Okay, that's a little bit about Miss Rizky Citra Islami. Now I want to greet Miss Rizky. Hello, Miss Rizky.
Hello, Shahla. Can you hear me?
Yes, I can hear
It's
you
clear
clearly.
enough? Okay, okay. Thank you. Thank you for your opportunity.
Rizky, how do you feel
Yeah.
about today's webinar?
Yeah, it's a very amazing webinar, and uh, I'm so happy because we can get four amazing speaker today, and all of the speaker deliver the material very good. And I hopefully in the second session for the participant can have the attractive communication with all of the speaker, and also for the feedback from the participant.
Okay, thank you, Mr. Rizky, for your time and willingness to join us today as a moderator.
Mhm.
So, without further delay, please welcome our moderator for second session, Mr. Rizky Citra Islami. The time is yours.
Thank you very much, the Master of Ceremony. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. I'm Rizky Citra Islami. I'm lecturer in a Department of Civil Engineering, Gajah Mada University. And right now, I teach for several materials in management and maintenance infrastructure, civil infrastructure study program. And thank you for management and maintenance civil infrastructure study program to give me opportunity to join the future of sustainable infrastructure and build environment after COVID-19 pandemic. And I will lead this session, and it's honor I can join this session with two amazing speakers. I would like to say hello for the two speaker, Professor Jibin Yang.
Hello,
Can you hear
everybody.
me? Okay, thank
Can you
you
hear me?
so much for, yeah, we can hear you clearly. Thank you for joining our webinar. And Dr. Aryo Muhammad.
Hello.
Thank you
Hi.
so much, Dr.
So
Yeah,
my
thank you
voice
so
is
much.
clear, isn't it?
Yeah, sure. It's
That's
clear.
great. Thank you.
Yeah. How was your feel? All of the participants also after the first session, did you still have energy to continue our second session? Okay, because I know that the struggle of doing online seminar is totally different with the offline seminar. What's the presentation from the speaker, and sometimes we can get link from our conference if we do in the offline seminar or offline system. And hopefully this pandemic can stop as soon as possible, then we can live normal and interact with each other. Also, I would like to say for all of the participants, if you go outside or join this webinar outside, I would like to remind that you still have to wear the mask and then follow the healthy procedure that like the Master of Ceremony said. Okay, in our second session, we have two speakers with a tremendous background. The first is Professor Jibin Yang. Actually, he is my kind-hearted professor. When I finished my master degree in National Central University. Thank you, Professor Yang. It's my pleasure to accompany you during this session. Thank you for being there. And Professor Yang will deliver the material with title The Aid from BIM for Better Infrastructure and Built Environment. And also we have the second speaker is Dr. Aryo Muhammad from Bristol University, United Kingdom. And Dr. Aryo will present the material with a title, A Deeper Look in Current and Future Trend of Tsunami Hazard and Risk Assessment in Developing Effective Tsunami and Mitigation Strategies. Okay, before we start the second session, I would like to read the rules for our session today. We will have 30 minutes for each of the speaker. And after all the speakers deliver the material, we will have a Q&A, question and answer for 15 minutes. And then all of the participant can drop the question in the chat box. Then I will choose one until two participants to deliver the question live. So I will choose which one of the best question, and then you can deliver your question live to two of the speaker. Okay, ladies and gentlemen, that's all for the rules, and let's jump into the main part of this session. Please welcome Professor Jie Bin Yang from Graduate Institute of Construction, Engineering and Management, National Central University. Have a virtual applause for Professor Yang.
Thank you, all of you.
Before
the invitation from the University Gajah Mada, I think that is my honor to participate in this event to share my research outcome.
Okay, thank you.
And my presentation, can I start now?
I would like to read your curriculum vitae first. Maybe, Professor, is it okay?
That's okay, no problem.
Okay, I would like to share your presentation, or from the committee, you will share the curriculum vitae. Okay, and I would like to read the curriculum or the experience from Professor Jie Bin Yang. He is a professor and chairman in Graduate Institute Program of Construction, Engineering and Management, Department of Civil Engineering, National Central University. And also, he is an Associate Director of Planning Office of Intelligent Health Innovation Park on NCU Bed campus. And then he has so many publications, such as a journal paper, 114, and then a conference paper, and also book chapter. Also, he has a research interest in construction management and project management, and then project scheduling and delay analysis, procurement performance evaluation and performance-based contract, and then knowledge management system development, and the last is application of BIM and IT construction in construction management. That's all the research interest. And please welcome Professor Jie Bin Yang, and you can directly to deliver your material approximately 30 minutes. Thank you.
Okay. Let me share my slides.
Yeah, sure.
Can you see?
Not yet. Maybe.
Can you see that?
It's still in the process. Okay. Yeah, we can see clearly.
Okay. My presentation title is The Aid from the Better Infrastructure and Built Environment. I think part of you, maybe all of you, knew the technology, and also it will be the key to solve the problem in the industry. So I think in the near future, all participants in the construction industry have to use it to solve their problems. Let me introduce myself to all of you shortly. I'm a professor in NCU in Taiwan. NCU is ranked top number 4 in Taiwan. based on the US news. Right now, I'm also the Associate Director in the Planning Office of Innovation Park on NCU Barter campus. That is a new campus. In the future, a hospital will be built to support medicine-related researches. One of my research topics is BIM-related work. Later, I will share with you my research outcome recently. First, let me use some slides to deliver the idea related to BIM I want to share with you.
The transportation industry understands that building and maintaining infrastructure is key to our global economy. One solution that promises to address many of our transportation challenges is building information modeling, or BIM for infrastructure. BIM is a collaborative work method for structuring, managing, and using data and information about transportation assets throughout their life cycle. It is about making information available to anyone who needs it when they need it. BIM provides critical information to all parties. It's about breaking down silos to enable users to access data during all project phases and throughout its life cycle. It illuminates who is building what, when each part will be built, the materials to be used, and how it will be constructed. Once built, the model becomes a virtual and accurate collection of the asset data used for system-wide decision-making. Today, BIM is being applied to transportation infrastructure, like highways and bridges. BIM helps optimize design, construction, and ultimately the life cycle management of transportation assets. By regularly reviewing the BIM model, DOTs are able to keep a close eye on schedule and budget. With BIM, projects are built virtually and in real life. It enables us to visualize solutions and avoid costly mistakes during construction by identifying potential risks and clashes during design. Corrections can be made before spending a single construction dollar. For example, New York State DOT used BIM for the Kew Gardens Interchange Reconstruction Project in Queens, New York during the third phase of the project. By refining and updating the digital 3D model through construction completion, New York State DOT has created an accurate and complete as-built record for ongoing maintenance, operations, and asset management purposes throughout the life cycle of the project. On this project, the benefits of BIM were successfully demonstrated. BIM helped adhere to construction schedule and cost. It provided a complete and accurate record of work, resulting in contractors receiving quicker payments. BIM substantially improved the accuracy and reliability of quantity workups verifiable by field staff who compared the data against the model. This helped to maintain better control and governance data, ultimately reducing risk impacts. BIM adds considerable value to those who implement it. It benefits agencies by helping them deliver a better coordinated product from beginning to end. To learn more about FHWA initiatives that support BIM, consult the...
I think based on this video, we can understand BIM can help us to obtain better quality facilities and also to obtain SBU records for long-term maintenance. But maybe we just focus on design and construction stages only? No, I don't think so. So I try to share with you for another video, and then we can understand how to use BIM for facility management.
Here's John, the happy owner of a new building. During the entire design and construction process, building information modeling was used. Architects and engineers created their designs with Revit, ArchiCAD, Tekla, Bentley, AutoCAD, and Autodesk fabrication to create BIM models. Contractors and subs incorporated additional information and utilized BIM for quality takeoffs, coordination, 4D construction scheduling, and fabrication. After construction was done, John received a lot of information. But what's John supposed to do with it? How can he access and use all of this information? John would have to invest in software licenses, expensive training, hardware, upgrades, and more upgrades. Voila, the solution exists, and it's called UBIM. UBIM can take all of those different data sources and combine them all together into one online navigation 3D model with access to all building data and associated manual of operations, manufacturer specs, equipment catalogs, images, etc., etc. UBIM is cloud-based, so John and his maintenance crew can access the building from anywhere, simply with internet access, a username, and a password. UBIM in action during a normal day at the facility. Chris, who works at the building, notices that one of the lighting fixtures isn't working. He quickly accesses UBIM, finds and selects the failing fixture, and sends a work order to fix it. Richard, the service guy, gets an email with a link. This link takes him directly to the exact piece that needs attention. Richard not only knows which one to fix out of the other 20 on that floor, but also he can get all of the specifications and manufacturer data he needs with a single click. Oh, the lighting fixture isn't easily accessible. Then he realizes he needs to take a ladder to be able to even reach it. So in just a few minutes, he knows everything he needs to know before he even shows up at the building. Additionally, if John uses any asset management system or even building automation systems, it can all be integrated within the UBIM 3D environment. Deploying UBIM is simplicity.
Based on this video, I do not want to focus on commercialized purpose software. We want to focus on the situation you face in the future. So maybe we can understand BIM can be a good tool to support maintenance works, but can we do the similar works in our real world? I don't think so. I want to ask you, what are you doing now? I think during COVID-19, the government and also the university may ask all of you stay at home and also save lives. But for all of you, I don't think that is not a joke. It is a good suggestion from the university, right? But you may wondering, can BIM help us to do the similar works? Before, during, and after COVID-19, I think all the students and workers can stay at home and try to simulate everything before real works can start. I think right now, some of the software company have developed a lot of some software package to help us to do BIM-related works. For example, Autodesk, Bentley, and also Trimble. They try to provide a lot of software. But right now, you should try to determine which level of you want to adopt BIM and to do their implementation. In general, we can try to divide the implementation level into organization and project. And then if you try to focus on the project level, and then you must try to select suitable software, and then you can input required budget and also to obtain required benefits. But I want to mention, even the software vendor tell us software is ready, but I think the software is not mature. To use different software and to integrate or maybe to combine all of the or some of the software is necessary in real situation. Right now, BIM can support whole life cycle of a construction project. BIM can also help us to do modeling and management works. If we focus on a maintenance stage, 3 available systems are required: computer-aided facility management system, building automation system, and also computerized maintenance management system. Let me show some examples for you. First, for computer-aided facility management system, it provides a space planning and management functions and try to provide the capital project management functions. So all of the work in this slide, we can try to complete by a computer-aided facility management system. For a building automation system, it can collect required information to help us in a smart grid, smart building, and even a smart city. Right now in Taiwan, some of the cities try to build a smart city. So BIM tools have been implemented in different buildings, try to collect required information. The last one, computer maintenance management system. It tries to help us to complete required maintenance works more efficiently. But when we try to use BIM for property or maybe facility and asset management, BIM can support the whole life cycle. But now I think we encounter a problem. How to build a BIM models for use. To build BIM models for new and existing buildings have two different approaches. I suggest you to see the movie, The Girl in the Spider's Web. That is a good movie, and then it can show you an idea to build a whole house quickly in the future. Right now, if we want to use BIM for property management, we have to solve at least 4 types of problems. How to build models? What are the maintenance process based on BIM, not traditional ways? Which FM software can support BIM model easily? And also, who are the skilled persons we can use BIM? They can use BIM for the required works. I don't think that is easy works. This picture try to show a periodic tables for successful BIM implementation. This table developed by NBS in United Kingdom. It covers different aspects to ensure successful BIM implementation. It includes strategy, foundations, collaboration, such as. But I want to tell you, this table provides a huge topics and issues. That topics and issues are useful and valuable for research and business. So maybe in the future, you can try to select some of the topics or issues to do your research and maybe to develop your business. Then let me try to share my research experience. For the past 5 years, my research team have completed several important research projects. I think the outcome of a research project influenced the real works and performance of BIM implementation in Taiwan. Let me share with you. First one, the sponsor from the Public Construction Commission Executive Yuan in Taiwan. I try to provide an implementation guide for public construction works. Second, the Architecture and Building Research Institute. I try to help them to solve some problems for better BIM implementation. The third one, the project supported by Railway Bureau in Taiwan. We try to provide a BIM implementation guide for railway project. The last one, a project supported by the Occupational Safety and Health Administration in Taiwan. We try to provide a BIM implementation guide for occupational safety and health works. Let me introduce the details with you. This project is supported by the Architecture and Building Research Institute. This is a government-owned research institute. This project tries to create and compare information from other countries, and then we try to provide the implementation strategy and also recommendation for the owners, for the governments. Some of the strategy and recommendation are on the way. So In this project, we try to identify the obstacle, the possible issues, and also the anticipated benefits. Also, we try to identify the challenge we faced and also try to point out the implementation guides is necessary. And also we try to provide some strategy for the government officers. This project supported by the Public Construction Commission. The Public Construction Commission is the central entity to government all public construction works in Taiwan. We try to provide a guide to implement BIM for the government's construction project. The purpose of this guide covers several suggested implementation process. So that is incorporated with conventional project delivery procedures. So the government agents can use this guide to do their implementation works in a correct way. If you want to read more information, you can try to find a paper published in Journal of Building Engineering. You can find it in the web. Another project is supported by the Architecture and Building Research Institute. We try to complete the project supported by this institute. The project provided by a guide for select BIM uses for building construction project. A BIM use is a case to show the function of BIM to solve real problems. So the government agency can use this guide to do their implementation works by correct language, because traditionally, the government may just write the country language by their understanding related to BIM. So we try to provide a guide and then use that guide. The government agents can just select some of the BIM uses, and then we can try to provide information how to government the designer and contractor to do their correct works. So we try to provide a procedural materials so the government agency can try to follow by the 5 steps, and then they can try to make sure their contractors can have the correct language to ask the designer and contractor to do their BIM related works. Now, there are 3 cities in Taiwan have developed the platform to help the designer and the contractor to solve the problem by use BIM to be a tool to help government officer to issue a building permit. This project targets on several problems of applying BIM to promote a drawing, delivery, and reviewing method to issue the BIM permit. So we try to focus on the procedure for obtaining building permit, and also we try to provide 2 approaches for obtaining BIM permit with BIM. So we try to solve all the problems, and then we try to make some recommendation on each step for different approaches. This project try to provide a railway BIM guide. The railway bureau will be the central entity in Taiwan. They try to government all of the local government and also railway related entities. We have complete Taiwan's railway BIM guide, and also we try to provide BIM implementation guide for the railway bureau. Also, we try to discuss the issues for implementing BIM for FM in railway domains. This is the whole picture for the railway BIM guide. It covers the procedure reference manual and also tendering reference document. And finally, we try to provide BIM development standard and specification for use. This project is supported by the Occupational Safety and Healthy Administration in Taiwan. In this project, we provide a BIM guide for execution occupational safety and healthy works. The designer and contractor can use the BIM element we developed to do their works. All BIM elements are developed according to the rules and regulations in Taiwan. So they may just download the BIM element and try to incorporate the BIM element into their BIM model, and then they can try to do their simulation. Right now, some of the contractors try to use the model to do their application related to occupational safety and health protection works. Right now, many construction projects use BIM in design and construction stage in Taiwan. But when the government agents want to receive all the model and outcome for reuse in the future, the government agency encounter a lot of problems. So we try to discuss the problem when receive the model and outcome from the projects. After we discuss the problem in different perspectives, then we can try to understand the real problems we have faced. So we develop a standard to correct required models and outcome. We clearly discuss all the required information according to the real project delivery system in Taiwan, and then try to develop the standard when they try to complete their BIM model and documents for submission to the government agency. I think all of the project participants related to BIM face the similar problems to find out required BIM resource. So when they try to find the resource to use in their project, they may just find the resource in the Google, but I don't think they can find suitable document, suitable model, and also suitable template for use. So we try to develop a platform to create required BIM resource for executing building project. This year, just the first year for the project, we have completed the planning works. In the future, the platform we may contain a trouble. Based on the trouble, the user can easily obtain the required resource for their projects. So right now, let me try to share some interest information in the future. I think maybe you are interested in them. First one, if you want to do your FM works with BIM, what are the keys to do that works? I think the BIM model must ready for use. Otherwise, we cannot do that. In Taiwan, most of the government try to do FM works with BIM, but they encounter a lot of problems. The major problem would be the BIM model. If we try to build the correct BIM model, we must try to consider the following issues. First, model must be suitable for use in operation and maintenance. Second, information must require for facility management. Third, the model must correct, and also the element must with correct correlations, dimensions, and also quantities. Otherwise, we cannot do our maintenance works. Also, the BIM elements must represent correct maintenance elements of facilities. The final one, the model must compatible with facility management system or platform. Otherwise, we cannot do that. But the BIM model must be compatible with facility management system and platform will be a key issue. But I think most commercialized vendors have tried to enter this topic to develop more easy use system for you. If you want to do your facility management worse, I suggest maybe you can try to read a BIM guide for facility management issued by the GSA in the United States. They try to provide a clear guide. That guide can help the user how to do their necessary work. In Taiwan, most of the government agencies try to follow the similar guides, and also we try to in this guide, it provides clear requirements and deliverables. So in Taiwan, we try to develop localized standards based on the IFC and COVID. So some of the governments, they try to issue their standard. The contractor must submit their BIM model. The model must contain the information for maintenance. Otherwise, they cannot get the final permits to complete their project. In the future, I think to use BIM to do facility management would be very possible. If you want to build a comprehensive digital facility management approach to do your facility management work based on BIM, I propose this graphics for you. In the future, maybe you can try to sit in the office to do your facility management work. But if you want to do that, your organization must have at least 4 guides. First, owner's implementation guide ready to BIM. Then you must have advanced facility management platform. That platform can input or can compatible with BIM models. And also the office must have a BIM implementation guide for new and existing facilities. Otherwise, you cannot collect all the required information for all of your facilities. If you want to do that, there are a lot of issues you must try to solve. Roadmap, regulation, contracts, a lot of information. So you may try to solve them one by one. Otherwise, you cannot develop a complete and also useful FM facility management completed software or system for you. Finally, I want to use this graphics to share with you some ideas. This is a graphics shown in the World Economy Forums. It provides 10 advanced tools for construction industry to obtain better infrastructure and built environment in the future. I think BIM is a vehicle to modeling and recording information. So if you want to collect required information and also to perform necessary modeling before design and even before construction, you can try to use some of or part of the tools shown in this graphics. Hope you can find the interest materials by yourself on the web. Those are required tools in the future. In my research project and maybe in my research areas, we try to focus on part of the tools in this graphics. It's very, very useful. I think that will be hard and safe topics and tools in research areas. That's my presentation. Thanks of you.
Okay, thank you so much, Professor Yang, for the amazing presentation related to BIM as the aid from BIM for the better infrastructure and built environment. And I'm very amazing to the BIM application in Taiwan. they try to insert the BIM concept in the whole process, not only for the construction, right, Professor? Because I see also for the transportation and then all the facility management in Taiwan try to adopt the BIM concept into their daily use like that. Is it?
Yeah.
Yeah. Okay, okay. Thank you so much, Professor Yang, for the amazing presentation. And ladies and gentlemen, we will have a second speaker, Dr. Aryo Muhammad. Before we move to the Q&A, and Professor Yang, I'm sorry, can you stop the share? Okay, thank you so much. And move to the second speaker, Dr. Aryo Muhammad. Please
Hello.
for yeah, hello, Dr. Arya Muhammad. How are you today?
I'm good. I'm good. I'm good.
Okay, so you have been finished for PhD and still stay in UK for research, right?
That's a good question. So I finished my PhD like I think 3 or 4 years ago, and then I'm working as a research associate in England. Actually, I have gone back to Indonesia, but because of COVID-19, my contract has been extended. So I'm still working in University of Bristol until next year. I don't know, maybe the next 3 years, I don't know, but currently it's until 2021. So yeah, it's kind of, I'm working remotely. So I'm still have my PC in Bristol, but I'm working from Indonesia right now.
Oh, okay, okay. Hopefully the COVID-19 is already solved in Indonesia, and the next year you will have a better better to maintain your job, I think. Okay, thank you so much, Dr. Arya Muhammad. And please, Komite, can you help me to show the curriculum vitae for Dr. Arya Muhammad before he start for the presentation? Okay, thank you so much. Dr. Aryo Muhammad, he is a PhD in Civil Engineering Department, and also he is an alumni from Taiwan. Okay,
Right.
and he finished there.
I'm so happy to meet Professor Yang. I mean, yeah, even though we haven't met in Taiwan.
So,
Okay.
some Chinese.
No, I cannot speak Chinese.
Same with me, Dr. Aryo. I just finished the master in Taiwan, but I cannot speak Chinese. Okay, and Dr. Aryo Muhammad finished the PhD in Civil Engineering in 2018 and the master in National Taiwan University of Science and Technology in Taipei, Taiwan in 2011, and for the Bachelor of Engineering in Muhammadiyah University of Yogyakarta and finished in 2009. Next. Okay, he has some research experience, also the work experience, and now he tried to develop a tsunami evacuation plan in bronze area, Japan and Indonesia, start from 2019 until now. And also he is a research associate at Civil Engineering Department in University of Bristol, and also he is a junior lecturer, right, in Department of Civil Engineering, the Narotama University, Indonesia. Okay, Dr. Aryo Muhammad, it's time to you to deliver the material, and I will give you approximately 30 minutes for deliver your material. And
I think you need
you
to
have any
allow me to
question?
share the screen.
Oh, okay.
Yeah, I haven't been allowed yet.
Okay, okay. Can the committee help me to allow the presentation? Okay. Okay, Dr.
it's good.
Arya. Okay, Dr. Arya Muhammad, you can prepare your presentation first, and the 30 minutes later, it's time for you. Thank you.
I think you can show my presentation now, right?
Yeah, it's clearly presented there.
Okay, thank you very much. First of all, it is I'm saying thank you again for from the Vocational School of University of Gadjah Mada. It is an honor for me, to be honest, to speak in front of Professor Yang and other students and other participants here. As you may know that I graduated in National Taiwan University of Science and Technology. I've been in NCU as well to meet a lot of Indonesian friends there. So hopefully Professor Yang's experiences, which is really rich, it will absolutely brings new knowledge and then maybe new perspective for the young engineers to do what they're gonna doing in the future. And actually today, as my work in the last 6 years is mainly concerned in tsunami and earthquake hazard risk assessment. So I'm gonna try to present regarding from tsunami hazard risk assessments to evacuation planning development by looking at case study in Padang, Indonesia and Kuroshio, Japan, in Kuroshio Town, Japan. These two places are the main works that I'm currently working on, because I'm working on developing evacuation planning in those two cities. But actually, the tsunami hazard and risk assessment parts has been explored more in the last, like from 2014 to 2018. So I do hope that my current sharing can open our perspective regarding the trend of tsunami hazard and risk assessment in those two countries. And my content today is actually, I'm going to focus on at least 6 things. The first one is, of course, I'm going to introduce you regarding why tsunami and hazard risk assessment is very essential, specifically in Indonesia. And then maybe some of you didn't really familiar with the concept of risk itself, even though I saw Professor Fujita has explained something regarding the concept of risk. But it's a little bit different with the concept of tsunami hazard risk assessment. So I'm gonna give a brief idea, and then we are going to my past experiences in tsunami hazard analysis for Padang, Indonesia, and then some idea regarding mitigation strategies, and then my current work in the last 2 years about the tsunami evacuation plan in Kuroshio, Japan, and then what future engineers can do. As I only have 30 minutes, I hope I can present all of this. But like the first things that the first question mark that we would like to ask when we discuss regarding tsunami hazard assessments is how important it is, specifically in Indonesia. If you look at the data, like globally, 18 tsunami-genic events. If I say tsunami-genic events, it means tsunami that occurred induced by the earthquake. At least 18 of them occurred in the last 50 years. And it produced a total loss of about more than 500 billion US dollar. And with the fatality number of about more than 250,000 people. But you may notice that this number is actually quite anomaly. Let's say for the economic losses, about more than 500 billion US dollar, most of them coming from 2011 Tohoku earthquake. On the other hand, in terms of fatality number of more than 250,000 people were coming from the Aceh Andaman earthquake in Indonesia. So if we look more closely to Indonesia, then we already know that we are placed in interface among several plates, and it makes us face a lot of earthquakes every year. If we look at the data in terms of earthquake for the magnitude of more than 5, we currently find about 500 earthquakes in the last 20 years, from 1994 to 2014. It means excluding the Palu earthquakes, or about 2 earthquakes per month. It is not small earthquake, it's significant earthquake. So we face monthly significant earthquake, more than 2 in the whole region of Indonesia. And we have also needs to know that about 34 of those earthquakes actually induce tsunami. And then another important area, even though currently people concentrations or attentions leads to south of Java, specifically from all the coastal areas in the line of South Java. But actually there is another segment that are very interesting to be studied, which is actually in the Mentawai segment of Sunda subduction zone, which is the failure probability of the Mentawai segment in Sunda subduction zone have increased. If you look at the past data, the 2004 and 2005 events, if you look at the map here, this is 2004 event. And then after 2004 event, it triggers another failure in the segment of Sunda subduction zone, which is in the red color. Here is actually 2000 with the magnitude of 8.5. We call it a Nias earthquake. And then these 2 events may actually lead to produce the of these whole segments, which we call as a Mentawai segment, because the last significant tsunami-genic earthquake occurred in this part is actually about 200 years ago. more closely look at the city around here, we can find some urbanized city like Padang, Pariaman, and then Bengkulu. So if
Hello, Dr. Aryo. Do you have a problem for the connection? Hello? Hello, Dr. Aryo. I think Dr. Aryo has a problem for the connection. We try to fix it, or how about from the committee, we would like to wait for the Dr. Arya. Oh,
sorry.
okay, sorry.
What's going on?
Sorry. Yeah.
You don't know?
I don't know, because you lost your connection maybe?
Okay, sorry.
Okay,
anyway, the connection is fine. I don't know.
Oh, okay,
Yeah.
but you.
Okay. Yeah, I'm gonna continue. I think this is where I speak before we stop the connections. So the thing is actually I highlight that one of the most important part in which can produce significant tsunami-genic events in the future is actually from the Sunda subduction zone. That's why we lead to one of important study areas, which is Padang, Indonesia. Actually, in 2010, I think like a researcher from Germany and Indonesia, they built a very strong research work regarding tsunami hazard and risk assessment in Padang. And further, they developed into the tsunami early warning system for Indonesia. But we want to explore more regarding what we can improve in terms of tsunami hazard and risk for Padang area, because as we know that we do have around almost 1 million people living in Padang city. And then this is like one of the most urbanized city in west of Sumatra. And then, of course, it positioned directly face the Mentawai Sunda zone. That's why Padang is extremely important. But first of all, before we discuss about tsunami hazard assessments in Padang, I'm gonna explore more regarding the concept of risk itself, so we can have a clear idea of what I'm talking about today. So if we're talking about risk, then it means the product of hazard, exposure, and vulnerability. And if we discuss about tsunami hazard assessments, then tsunami hazard means we would like to quantify how large the tsunami potential occurred in our target regions. For this problem, it means Padang, let's say. Then if we discuss about the quantify how large the tsunami potential, then it means we define some hazard parameters, for example, like depth, height, velocity, or momentum flux. Assessments, there are another extremely important data, which is either infrastructure data, let's say like building information, type of building, is it steel structures, reinforced concrete structures, or wood structures, and of course, number of populations. By using the information of hazard, like how large
Dr. Aryo? Hello, Dr. Aryo. Do you have any problem again about the connection? Hello, Dr. Aryo? Can you hear me, Dr. Aryo? Okay. Sorry for this situation. So, okay, wait a minute. Is Dr. Aryo still in this participation? Dr. Aryo? I think he lost the connection because he just left the Zoom meeting today. Committee can, hello, committee? From the committee? Dr. Aryo?
I'm very sorry. I don't know.
It's the same. Okay.
Oh my God, it's not really good. I'm sorry.
Okay.
I'm just continue what I'm talking about.
Okay.
Yeah. So if we discuss about the risk, then after we measure the tsunami hazard, then we have another two important information, let's say infrastructure data and number of population, then we can work on vulnerability analysis. The vulnerability analysis actually, we try to estimate, let's say, the number of fatalities using the population data, or the probability of building collapse for a given tsunami intensity, like how, let's say, for a given 10-meter height of tsunami, what is the probability of building collapse in that area? Such kind of things from vulnerability analysis, then we can produce what we call as a risk. So let's say we can't exactly say that if the future earthquake happens in Padang, let's say with a magnitude of 9.0, then we can clearly say that the loss or the people could die of more than, let's say, 2,000 people, or the economic losses of more than $1 billion US. Such kind of things can be measured or quantified when we have combined those hazard, exposure, and vulnerability. And then the next question mark is, after we have those informations from risk, then what can we do? And it goes to mitigation strategies. There are several mitigation strategies. Professor Fujita says a hardware countermeasure or a software countermeasure. We can combine, or we can categorize those mitigation strategies in either hardware countermeasure, let's say like building seawall, or software countermeasure, let's say by building tsunami early warning system or evacuation planning development. So such kind of mitigation strategy is actually extremely important. And something that I need to emphasize as well in my talk is actually, if we discuss about tsunami hazard and risk assessment, even for multi-hazard, let's say either when we combine tsunami with earthquake, with landslides, then it always involves multidisciplinary works from engineer, from researcher, from local government, even from the society, because we try to implement the evacuation plan, then we need them. And because this is multidisciplinary work, then like a lot of collaborations needs to be done. Let's say in our research group in UK itself, we collaborate with many backgrounds, let's say from industry, from society, with various countries in Canada, Japan, Indonesia, Mexico, and such information give us a rich idea regarding what we can see in the field itself. And then if we have the mitigation strategy, then we do need to see what is the problem in hazard assessments. There are at least three things that we need to understand when we look at the hazard problems. The first one is actually source modeling, and then the second one is propagation, and then the third one is foundation. If we look at the, we are gonna explore later on, but when we look at the hardware countermeasure, this is like one example that we can see from Japan and Padang. This is actually in Kuroshio town, and this is in Padang. We call it a tsunami evacuation shelter, or in Padang they call it tsunami evacuation tower. So they try to build a building which can save people and located very close to density area, most populated density area, like let's say in the middle of the city. Such building actually can evacuate or can accommodate all people who are running here. And if you look in the ground floor, it's normally have like open space, so the water can flow within those buildings. This is in Japan, and what very amazing in this building is actually in the top floor of the building, they actually provide monthly food and all the things that we need during the evacuation. So when the people are running there, they still have all the things that they need to survive. And this is an example in Padang. As far as I know, they already installed hundreds of tsunami evacuation shelters, and they named several buildings to be used as temporary tsunami evacuation shelters, which is amazing. If you heard recently that some researchers, as far as I know, it is from the University of Gajah Mada, that has launched the idea regarding the tsunami potential in south of Java. Then I think Padang is one of the best example in Indonesia, how they prepare for the tsunami in the future. And I know that in Bantul as well, they already installed the tsunami evacuation shelter, which is a very good news. I do hope like other places like Cilacap, Pacitan, could improve more in terms of tsunami hazard mitigation strategies. And then let's go back in tsunami hazard issue. There are first things that we need to look. The first one is actually the earthquake source modeling. So this is like a fundamental thing that we need to learn or understand when we discuss about tsunami hazard. Earthquake source modeling is actually how we model the slip, because if we discuss about earthquake, it means there is the formations occurred in the seabed. Tsunami-genic earthquake, it means deformations occurred in the seabed due to slip that has been launched from the source area. Let's say here is actually in Mentawai Sunda zone, and this is the source area developed by Muhari et al. Using some paleogenetic measurements that has been developed by Natawijaya et al. But the thing about the first scenario that normally researcher or other people use is actually deterministic scenarios. So if we discuss about deterministic scenarios, then it means we only have 1, 2, or 3 worst case scenarios. Why they take worst case scenarios in order to model the source modeling? Because if we discuss about the risk, or if we about to predict the risk, then it means we want to know what is the worst situations that we may face in the future. So normally when people try to do the earthquake source modeling in order to predict the tsunami, then they normally take the maximum future cases. Let's say here is with the magnitude of around 9.0 or 8.92. However, the problem regarding the deterministic scenarios is there is 2 problems. The first one is when we use deterministic scenario, it means we couldn't accommodate the uncertainty of the future. We know that when we predict something, then a lot of uncertainty that we may face. Let's say if we say we predict the future of tsunami, we couldn't only say that there would be a tsunami of 30 meters, but it could lead in misunderstanding of the society, because 30-meter tsunami of course can occur in the future, but the rate or the probability is very, very low. One of our study in probabilistic, in time-dependent probabilistic tsunami hazard modeling, we could clearly see that very low such tsunami occurred. We couldn't see what is the range. Actually, the tsunami can occur from, let's say, 1 meter or 0.5 meter into 30 meter. Such information cannot be delivered when you use deterministic scenario. Another thing that we found in our studies, actually, deterministic scenarios can oversimplify the tsunami hazard, and of course, it leads to inaccurate mitigation plan. Therefore, several researchers and in our group as well, we're coming what we call as a probabilistic scenarios that has been improved, that has been done several decades already. However, the problem regarding the probabilistic scenarios is we need a proper considerations of regional characteristics. This is including uncertainty in size. In size means what is the size of this rupture plan, and then how about the spatial slip? So this is the slips. How about the distributions of the spatial? How about the distributions of the slip along the plane? Such information needs to be considered carefully when we model the probabilistic scenario. And then another tsunami hazard issue, if we discuss tsunami hazard, is actually the inundations and propagations that is leads to the data of DEM and bathymetry. DEM is digital elevation model, which is the information of land elevations, and bathymetry is actually the information of how deep the ocean is. Such information needs to be provided in high resolutions. High resolutions, I mean at least 10 meters, because in our study we found that if the tsunami hazard assessment is carried out in the resolutions of about 50 or 30 meters, then the accuracy is relatively worse. So we need at least 10 meters. Luckily, I think in 2016, if I'm not mistaken, Indonesia has launched our local DEM and bathymetry data with high resolutions. That is really good. I do remember when I'm working in 2014 of tsunami in Padang, we still don't have a very rich information of DEM and bathymetry, but now we do have, which is very helpful. And the issue regarding DEM and bathymetry can help us to produce more accurate tsunami hazard to this assessment. And then another issue is regarding tsunami hazard parameters. Normally people only use tsunami depth and height, but actually we can play with velocity and momentum flux. And then normally in terms of typically for risk assessment in Indonesia, we only have deterministic scenario to model the earthquake sources and as well as to quantify the risk. And then some fatality estimations and vulnerability assessment of tsunami evacuation shelters has been excluded in the past study, specifically for Padang areas. So such kind of things comes into our mind, and then we try to build another concept of tsunami hazard and risk assessments, which more that can produce rich informations in terms of hazard and risk, as well as can build a better evacuations modeling. And this is like a small example of how you would do tsunami simulations. This is an example where I did tsunami simulations in North Maluku, in my hometown, actually from east of Indonesia. You can clearly see with different minutes there is tsunami coming from south of Sulawesi here, sorry, North Sulawesi here, then it moves up to about 2 hours to Halmahera and then to Ternate. So this is the tsunami height in meter. And then the next things that I'm gonna discuss is actually tsunami hazard assessments in Padang, specifically tsunami simulations. So we develop this model, stochastic tsunami simulations, actually with using probabilistic approach that considers many earthquake source modeling. So first of all is we normally doing regional dependency study. So we collect all the informations of the past earthquake in the Sunda subductance zone, which is taken from Goddard All, which is my supervisor. This is taken from one of the databases for earthquake source modeling in the world that has been developed in King Abdullah University of Science and Technology in Saudi Arabia. So we collect of those past informations, then we develop our own stochastic earthquake source model. You can see here, if this is deterministic source model and this is our probabilistic source model, we can have like thousands of earthquake source model, and each source model can produce the hazard and then further propagate it into the risk. It means we do have rich information of hazard for the future information. So if you have this stochastic source model, then we can easily run the tsunami simulations, as I say in North Maluku cases. So we using these thousands of earthquake source model, we implement stochastic tsunami simulations. It's running in Monte Carlo in MATLAB, and we use linear and non-linear shallow water equations. This is like common equations that used to do the inundation and propagation modeling, and then we produce the results specifically for Padang. So this is one of an example of our study, specifically in my PhD. This is Padang City, and we try to take the tsunami height in 3 points, which is in Tabing, Purus, and Teluk Bayu. You may really familiar with Teluk Bayu, in the depth of around 10 meter, and we could clearly see that this is an example of deterministic scenario when you only have one information of hazard. But if you have implemented the probabilistic scenarios, then you will have a range of information of hazard, rich information of hazard. Like we don't only say that the tsunami height that may occur in the future in Padang due to magnitude of 9 is around 5 meter, the maximum. But we could say that, oh, the maximum could be more than 10 meter. There is such information can only be measured when you have probabilistic scenarios. And another example is when you look at the tsunami height along the coastal, like from site number 1 until site number 75 is actually in Padang as well. We could clearly see that by using the stochastic earthquake source modeling, we can provide rich information of tsunami hazard parameter. Not only, let's say, with a minimum of 3 meter, but we also can capture the tsunami height up to 50 meter, and we can like confident say that the future have such kind of information of hazard. If the tsunami event with a magnitude of 9.0 occur, then the tsunami height can reach up to 50 meter, let's say. And then by information of hazard, we can easily measure the fatality estimations using either combining the evacuation modeling and the population informations. In here, like we try to model the evacuation modeling using pedestrian and motorbike, and then we're using some existing case. Existing case means Padang actually provide 2 evacuation points, which is in here and in this point. And then by using those 2 evacuation points, when people are running, are they safe or not? Such of information can easily get when you already have the hazard informations, and then you propagate into the evacuation modeling. So that is the hazard part. And now I'm gonna explore more. My last topic is regarding development of tsunami evacuation plan, which is we implement using agent-based evacuation modeling. If we discuss the agent-based evacuation modeling, it means we focus on each person who running into the evacuation area. In here, the red point is actually the evacuation point. The location here is in Padang. So people here, you see in the magenta color, in the blue color, light blue color, are actually the people who will run in these 2 points. So we try to model how the people will evacuate in those evacuation points using agent-based approach, specifically using the software called MATSIM. And then for the study case that I'm presenting today is actually in Japan, in Kuroshio town. This is the study area. So this is the Kochi prefecture. So we do have the area here. Our case study is here, Saga, you can see here. near Ioki River. And this is the distributions of the people. So we assume that the evacuation occurred in the daytime, in the morning. It means people, most of them are outside the house. So around 2,000 people lives in Saga. And you can clearly see here the distribution of the people. Like this is actually houses. Many people are going to the market. This is market. This is a factory, and then some warehouse informations. And then another important thing when we try to run agent-based evacuation modeling is we need to have building data, and then we need network infrastructures. Building data, of course, is to distribute how many people lives inside the building. If we have the information of population data, then we have the number of household size within the building, then we can easily distribute the number of people inside those buildings, whether in house, non-house, district office, school, market, and etc. And then network infrastructures is very important. Of course, the first one is when we have primary road, secondary road, then we know what is the road that the evacuee or the people can use in order to go to evacuation points. And in Japan, of course, they are very developed country and they already prepared a lot of evacuation points. You can clearly see in those yellow points. Those yellow points are actually evacuation points already. We can compare with Padang here. Padang is only have 2 points. And then in our study, we recommend a lot of points near the hill, which is very, very, very sufficient in order to accommodate all the evacuation, all the evacuee, the people who go to evacuation point. But in Japan, they already provide at least about 17 points of tsunami evacuation points. Not only they provide tsunami evacuation point, they also build a sufficient area that can accommodate all the people who evacuate to those points. So we need those information in order to running evacuation model. And then we can implement so-called single mode, which single speed. It means we can only model the pedestrian, or we can only model the car or the motorbike, or we can implement multi-modes. It means we can mix it up. Either we can mix with a car and motorbike, or car and pedestrian, or pedestrian and car, or those three, pedestrian, motorbike, and car. We can do easily in Maxim using the multi-mode approach. And this is like one example of how we study the importance of tsunami evacuation shelter. If you remember in my previous slide, I show you the tsunami evacuation shelter in Japan. So it is placed in this location. The color represents evacuation time from 5 to 30 minutes. So if you place tsunami evacuation shelter here, then you can see the difference. The B panel, the B figure here is actually the case where there is no tsunami evacuation shelter. When we put a tsunami evacuation shelter here, we can clearly see that the evacuation time of the people are relatively quicker compared to where the case there is no tsunami evacuation shelter. This is with the single speed, so only single mode with 1 meter per second. And then we can also implement multi-speed model. You can, yeah.
Sorry, Mr. Ayo, your time is enough, but maybe you can shorten your presentation in 3 or 5 minutes. Okay, thank you.
Yeah, it will be done in 3 minutes, hopefully. So, and then we can implement multi-speeds model, which we combine between car and many speeds of pedestrian. Here is we implement uniform pedestrian speed from 1 to 2 meters per second. And you can clearly see the results here, and then as well as the evacuation time histogram. Like a lot of people are relatively safe with evacuation time of less than 20 minutes because the tsunami arrival time is about 15 to 20 minutes. And you can clearly see that normally people in Japan are relatively safe when tsunami coming because they already provide tsunami evacuation point the whole area. And then this is an example of how we run the evacuation modeling. You can clearly see how people are running into the evacuation point. This point is actually dummy point that we normally set up when we try to build the tsunami evacuation point that already accommodated all the evacuee which go to the safe places. This is an example of tsunami evacuation plan. And then there is the things that I'm gonna say. The conclusion is actually we need reliable effect source modeling and high resolution data of DM and bathymetry to develop more accurate future tsunami hazard and risk assessment. And stochastic tsunami simulations using high resolutions DM and bathymetry data might be one of the good recommendations, and we can easily develop into evacuation planning if we have a hazard and risk assessment. And the last thing that I'm gonna say to future engineers, Indonesia actually needs a lot of researchers in hazard, specifically for tsunami and earthquake. So I do hope that when you graduated, you can focus more in either tsunami or hazard assessments or even earthquake. And then when you become an engineer, please do involve in many hardware countermeasure development for tsunami mitigation strategies. That's all I can say. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, Dr. Aryo, for the amazing presentation today. And I am amazed because I know that the United Kingdom didn't have a tsunami hazard, right? But they tried to build the like research about the tsunami very great. And I think in your laboratory you will take the case study outside the United Kingdom to finish your research, right? Because the
I think another thing, I mean, linking to your statement, actually, and in UK they focus more on more undeveloped country like Africa or global in general. So most of research projects are focused in Africa and some underdeveloped country, and one of them is tsunami prone areas. And yeah, that's the things. Yeah.
Yeah. Thank you so much, Dr. Arya. Okay, ladies and gentlemen, and all the participants, we will move to the Q&A session. Right, we will have a 15 minutes of Q&A session, and I will read for Professor Yang and also Dr. Aryo. Both of you have two questions. It's two questions each.
I have received one question, right?
I think two from the Fahrisa and also for. Sorry.
I think I received one question. What the future engineer can do.
And the first question, because the first question is right in the beginning of your presentation from Fardi Kalumata. Did you see? And I will read it first for you, Professor Yang. First question comes from Fardi Kalumata. Name of agency is freelance engineer. He would like to ask, as we are know, when COVID-19 attack around the world forced everyone who work as engineer usual work at the office, but nowadays we must work from home, and not all the engineer ready for this condition, right? And would you tell me about 4D until 7D in BIM used for Revit structure? I know that Professor Yang have a more experience in using Revit structure. And maybe it's time for you, Professor, to answer the question from Fardi Kalumata.
Okay. I see the question is what the future engineer can do to manage the rework made using BIM, right? This question.
This is the second question, but the first question, the first is already right before in 11:26 EM. While you present your presentation from Fardi Kalumata.
From Kalumata. Okay, let me search it. Related to 4D, right?
Sorry?
The problem related to 4D.
Yeah, you. He want you to tell how about because right now in COVID-19, all of the engineers start to work from home, and not all engineers ready for this condition, this COVID-19 condition. And would you tell me about the 4D until 7D in BIM use Revit structure? I know that 4D is not yet open BIM, right? And 7D is totally open BIM.
Yeah. Right now, if you have the model, you can do a lot of work, including 4D, 5D, 6D, and 7D. But we must try to understand what is the purpose to use BIM to, for example, to complete 4D works. In construction works, if we can try to understand what can we complete in the construction site, we must try to simulate in advance. So 4D can try to simulate all of the works before the real construction. So I think I must try to mention the purpose of BIM implementation is very important. Right now in Taiwan, all of the government agency, we try to escalate. They must try to have clear objectives to use BIM. Otherwise, we cannot obtain the benefit after BIM implementation. So in the web, you can try to find many examples to use BIM to complete 4D, 5D, 6, and even 7 and 8D. So I suggest you must try to focus on real problem. What are the real problem? And also then you can try to think about, can you use BIM as a tool? I don't think BIM is a powerful tool. Maybe you can try to use traditional way to solve your problem. BIM could be an alternative to solve your problem. Please do not just focus on BIM to solve all of problem. Maybe you input more resource, but you cannot obtain efficient way to solve your problem. That's my answer.
Okay, thank you, Professor. Do you have any experience using BIM in this condition? I mean, in the pandemic condition, all of the engineer should work efficiently at home, and then only just a few people in the project. And how about Taiwan? Do you have any experience in this pandemic to solve the construction project problem using BIM in Taiwan?
Yeah, I think BIM try to solve the problem related to rewards. It means we do not make sure it be happen. It means we can try to simulate in advance, so rewards cannot be happen before the construction was. In Taiwan, when we try to discuss with engineer in construction site, there are many rewards. So with BIM, we can try to discuss how to complete their works. If we try to manage the rewards, that would be a burden to all of the participants. So try to think about what are the good timing to do their simulation. I think that would be a good idea. Please do not try to solve the problems to do it, because after you face the problem, you encounter the real problems. If you try to build a model, it costs time. It is not an efficient way. So maybe you can try to use traditional way to solve the rewards after they happens.
Okay, thank you, Professor. I think that I can conclude from your answer. We have to focus which one we can just finish the problem from traditional way in the construction project, and which one that we can finish it using the BIM concept right now, Professor? Is it right?
Let me try to illustrate in another way. I think engineer can do all works in conventional way, but with engineer must think about how to do their works more efficiently. For example, our graduate institute target on educate our students to be a good construction project manager. So in the class, we teach them how to use BIM to do their project management related works in advance. So in the future, they can try to understand how to incorporate BIM as a tool to solve their problems. To use BIM, I think engineer must have strong knowledge related to BIM and also related to engineer. So you cannot forget anything you learn in the undergraduate age. So in other words, engineer must have to know how to use BIM as an aid to solve their traditional problems. So BIM just a tool. They must face their real problems.
Okay, so just we have to face the real problem first, and then we have to divide it which one we can finish by traditional way, which one we can finish with the BIM 8, and then we have to have the strong analytical, right, Professor? As the engineer, which one we can doing efficiently. The key is the efficient for the finish the construction project during this pandemic, right?
Yeah, I agree that.
Okay. We want to move in the second question from, let me check it first, from the Fahrisa. Unmul or University of Mula Warman. I think it's come from Kalimantan in the center of Indonesia, Professor. What the future engineer can do to manage the rework may exist using the BIM, because we know that during the construction, we will have many rework and then a change and something else. It's time for you, Professor.
Yeah, I think to manage the rework, it is not a good idea. If possible, you must try to prevent reworks. So in the future, if you face the rework problems, then you must try to discuss with engineer. Can we try to simulate it with BIM to solve the problems? But I don't think to solve the rework problems after it happens, that is a good approach. So with BIM, right now, we try to prevent rewards. So in the future, I think the engineer can do anything with BIM to do their simulation works.
Okay, okay. I can resume from your answer, Professor. During this pandemic, and also we are as an engineer to finish our problem. A BIM is one of the eight, but we didn't have to forget the traditional way or the conventional way, we call it, to solve the construction problem, right? The key point of the construction can doing the smoothly, but we can have the efficient to solve all the problem in the construction. Is it right, Professor?
I agree part of you. To use BIM maybe just a efficient way. It may a burden way to do their works. For example, traditional maybe you have understand whole of the situations. So in traditional way you can solve it quickly. But right now, in some real cases, because they have the BIM model, they try to use the BIM model to do some complicated situation analysis. So it costs time, it costs money, and also they do not provide better ways. So I think we must try to focus on the core of the problem. Try to discuss BIM is a good alternative or not. Because I do not make sure BIM provide the best way, because it must try to input a lot of resource to do the simulation. But I think BIM provide an alternative. That would be an approach to think about it is better or not.
Okay, okay. Thank you, Professor. Maybe the last from me, Professor. In your viewpoint, you know that Indonesia is still ongoing to solve the COVID-19 problems, right? And how do you think if we want to solve these problems, and then what is the tools that we have to prepare to mitigate the next, maybe the next pandemic, if there is a pandemic later, using the BIM maybe, or using the another tools that Taiwan have finished, or maybe you have experience on that cases?
I think if we can use the web-based system, we can try to discuss on the web, and also we can try to simulate the possible problems on the web. So and maybe after COVID-19, web would be a tool, would be a platform to share the experience and also to do necessary analysis. So try to communicate, try to learn how to communicate with on the web. That is the necessary capability for all of the students. In the future, maybe we must face, we do not have the easy way to go into the construction site to do anything. So we must try to learn how to use the web, how to use the internet to do part of all our works. I think that would be a capability for the students.
Okay. Also, maybe we have to prepare the comprehensive digital FM approach, right, Professor? To this is the another way to solve this problem. Okay, maybe I will move to Mr. Dr. Aryo. to the another question. The question is come from Iwan Hendrawan from Ministry of Public Works Indonesia, Balai Besar Wilayah Sungai, Sumatera 5, right? The question is how tsunami shelter should be designed, how many shelters should be provided in Padang, and how about in pandemic condition? Should we make it double? Maybe because when it's come in pandemic and then all of the people stay at home, and how to design the shelter. Okay, time for you, Dr. Arya.
Yeah. First of all, thank you so much, Mr. Iwan or Mr. Hermawan. Maybe later when I answer the questions, I'm gonna share specific information that has been based on our experiences regarding the work in Padang. So first of all, if we discuss about the tsunami shelters, then first is we need to learn what is the locations. The locations is extremely important. And as I mentioned in my previous presentation that I'm gonna share here, here, if we look at the in Japan case, the locations of shelters is actually in the center of the city, because when it is very close to in the center of the city and very far, relatively far from the evacuation point. So if you remember, the evacuation point is through this cool outside area. So that is one thing that we need to consider that we need to learn from that. Another thing, when we try to build the tsunami evacuation shelters, besides there is a guide that already provided in order to build a tsunami evacuation shelter, but there are several parameters that we need to consider. The first one, we need to understand the height of tsunami or the depth of tsunami. In land, it means the depth, because we discussed height means the level of tsunami from water sea level. But if we discuss the depth it means the water level above the ground. So first, what we need to do when we design tsunami evacuation shelters, we need to have a proper tsunami hazard assessments. As I mentioned here, let's say here from these simulations, we can have what we call as a tsunami evacuation map. Sorry, tsunami inundation map. I'm gonna show you one of our results here. This is in my paper in 2017 in Padang. You can see this is tsunami hazard map. Belongs to tsunami depth. We can have the maximum case scenarios with the magnitude of 9.0, and we could clearly see the tsunami depth here. If we do have the information of tsunami depth, then we can convert into the size of or the height of the tsunami evacuation shelters. Like, what is the ground floor appropriate height that we need to design in order to do or in order to build the tsunami evacuation shelters. The second thing is actually the speed and momentum flux. So the speed of tsunami is also related to the force. So when you know the force of tsunami that hit Padang area with regard to tsunami hazard assessments, then we can understand how we can build a strong tsunami evacuation shelter. So at least we need those three parameters: tsunami height or tsunami depth, and then tsunami velocity and momentum flux. And another thing that is also extremely essential is actually tsunami arrival time. Tsunami arrival time is the time when tsunami arrive in that point or in the coastal line, because we don't want to provide we build the tsunami evacuation shelters which is very far from the tsunami, from the let's say from the coastal areas where people are going there too far, then the tsunami already hit them. So we need to consider those four parameters before we design. I think I don't know whether the PU already have the guide for tsunami evacuation shelters, but I do remember that USA already, the FEMA I think already provide the tsunami evacuation shelter guide to build in specific hazard area. I do remember I explored that part. And another thing is actually in Padang, I do remember one of my colleague in tsunami researchers in Indonesia, which is Mr. Muhari, suggested what we call as a tsunami hill. So tsunami hill is actually located in Padang, but he mentioned like far north. We couldn't see in this map, like some free area, green area here that we can build tsunami hill that can change for tsunami evacuation shelters. That's the first thing that I'm gonna answer. And then how many tsunami evacuation shelters? First of all, I think if we decide how many evacuation shelters, we need to study more to define what is the actual number of tsunami evacuation shelters that can build in Padang. But I'm gonna highlight what we face or what we do my research. This is actually published in this journal, if you interested, Natural Hazard and Earth System Sciences, with the title Tsunami Evacuation Plan for Future Megatrust Earthquake, blah, blah, blah. But I'm gonna explore more regarding how many TS here. So here, I had the information of tsunami evacuation shelter in Padang, which I got from NPB. But somehow, unfortunately, when I access the website, I do remember like a couple years ago, I couldn't find this information anymore. Maybe, I don't know, maybe they have updated, maybe they have a new number, I don't know, but this study have been done around 3 or 4 years ago, so it's quite long. So we do have 23 tsunami evacuation shelter, but remember that this 23 tsunami evacuation shelter, I think only two of them are a proper tsunami evacuation shelter that has been built by the government, either local government or the central government. So we do have, they do have, and then the BNPB already recommended about 23 tsunami evacuation shelter, including the proper tsunami evacuation shelters. These temporary tsunami evacuation shelter are actually coming from several buildings like mosque, hotel, and then some government office. And then we try to assess whether these 23 tsunami evacuation shelters are already enough in Padang or not. So we try to do not tsunami, we didn't using agent-based modeling because we haven't implemented our current model that I've done in the last 2 years. So we only calculated directly using simplified model, which we calculated based on the distance. Let's say if you have the distance from, so it's easy V S over T, like that's such kind of simple calculation. And then we try to see whether tsunami evacuation shelter are already sufficient to evacuate the people. And in D panel, you can clearly see here, if we have those tsunami evacuation shelter, we still need some evacuation shelter in order to accommodate the people. Because if you look at evacuation time here, we still have about 40 minutes of evacuation time in order to go to safe area for the people living around here, where the tsunami arrival time in Padang is about 10 to 15 minutes. It means we can double or we can triple the number of tsunami evacuation shelters in Padang area. The exact number, I don't know, because we need to study more based on tsunami hazard assessment. I'm so happy if, you know, if you give me a chance to study about this one, because this is what I'm doing in my hometown, which is in Ternate, North Maluku, where I present the tsunami hazard or future predictions for tsunami hazard in North Maluku. And I'm happy to work on it to define how many tsunami shelters that can be built in Padang. The last thing that I'm gonna explore to answer your questions is actually what we study in Teluk Bayur. So this is another paper that
Hello, Dr. Aryo. I lost the connection again.
Oh, lost the connection?
Oh,
hello?
No. Okay. It's okay
yeah.
now.
Okay,
Okay,
so
but maybe you have
okay,
to shorten
cool.
your answer. Okay.
Sure. And this is where we develop where so in Teluk Bayur, the case where another part which is in Padang Teluk Bayur, right now, as far as I know, maybe you can correct me if I'm wrong. There are 2 points that has been assigned as tsunami evacuation point in Teluk Bayur, but actually it's not sufficient. If you look at tsunami evacuation time here, you see that more than 30 minutes people evacuate to those 2 points. So what we can do is we add another evacuation point in those hilly areas. So what's so good about Teluk Bayur area is you don't need to build tsunami evacuation shelter in Teluk Bayur area. Rather than you only need to open the forest area to be the evacuation shelter, temporary evacuation shelter for the people. That's what I can answer. Whether we double during the pandemic, I think the pandemic is. We do hope that there is no significant event during this pandemic. Otherwise, it's gonna be very bad. Because if we discuss about evacuation, it means we collect all the people to go in one area, which is not really good. I think that's all. Thank you.
Yeah, thank you so much, Mr. Aryo, Dr. Aryo. Sorry, actually, there is still have one question for you, but the time is finished and the time is enough for this session. But maybe if you allow, we would like to ask you to share your email. Maybe the participant want to email you for another information. Is it okay, Dr. Aryo?
Yeah, I'm gonna write in the chat box.
Okay. Thank you so much. Actually, time is up for all the participants. Thank you for the two speakers, two amazing speakers. We would like to give the virtual applause to our amazing speakers. Thank you so much, Professor Young and also Dr. Aryo for the opportunity today, and also thank you for your time that you spend for this event, and hopefully we can meet again, not only in virtual only in the offline and something else in another event. I as moderator, I would like to say sorry if I have some mistake during this session, and I will return to the master of ceremony. Thank you so much, Professor Yang and Dr. Aryo Muhammad.
Thank you, all of you.
Thank you.
Thank
Time
you so
for
much.
master
Bye.
of ceremony. Thank you.
Okay, thank you, Mr. Rizky, who has been moderating and directing this session of conference. And all of the speakers in season 2, Mr. Ji Bin Yang and Mr. Aryo Muhammad, we like to say thank you very much. We have heard and learned so much from our second session speakers. We got a lot of new perspective also that will be very useful for our next study in civil engineering. Now, before we begin to the next agenda, I would like to tell you that the attendance link will be closed at 13:30. So for all the participants who haven't filled attendance, please as soon as possible. Now we will talk a little bit about what we have learned from this second session. If I didn't hear wrong, Mr. Yang has been talking about BIM, Building Infrastructure Management, and how important it is to simulating our works before the construction begin. And Hakim, how about you? What have you learned from this session of conference?
Yeah, I've learned so much, Lala, and we got a lot of new perspective from the both speaker. Firstly, from Professor Jin Bin Yang, if I may. Professor Jin Bin Yang has tell us about the importance of BIM and useful of BIM in order to aid the better infrastructure and built environment. And also from Dr. Aryo Muhammad about the tsunami hazard and risk assessment to evacuation planning development, and also a problem in risk assessment in Indonesia, especially the tsunami hazard assessment in Padang. And I hope I agree with Lala. I hope this conference, opportunity could help us in the next future, and also could be useful in our next study in the future. Maybe that's all, Lala.
Okay, thank you, Hakim, for your answer. I would like to thank our speakers also in first session, James Zulfan and Ms. Professor Masaharu Fujita, for your time and willingness to share your experience and knowledge to all of the participants in this room.
Yep.
Okay, now we will immediately move on to the last session or agenda in this today conference, that is closing ceremony.
Yep. The honorable distinguished guests,
All of the participants, ladies and gentlemen,
we are very honored to have you with us in this afternoon. We have had a really productive time and inspiring time together, but unfortunately, we didn't have much time because our time is limited. And this event is about to come to the very end.
thank you, and thank you very much to all of you that have been joining in this grateful event. I hope you found the presentations on this conference are informative and helpful. And before that, I'm also would like to thanks for our sponsor who have helped us to launch this conference. To PT Selaras Karya Wahana Nusantara or SWAN, I would like to give our big gratitude to you. And greeting from Yogyakarta, and till we meet again, perhaps in the next conference.
Yep. And this conference will be held on the next week's. The topic of the second conference is about the application of building information modeling and construction planning. So feel free to join us and catch the latest information by following our social media, of course, in Instagram, Line, and in website.
For the Instagram, you can follow at creationugm and at BIMDTS. And for the website, you can click on www.creation/ugm.com.
Okay. For the last one, thank you for joining us. May all of you have a great life now and after. Thank you and wassalamualaikum warahmatullahi wabarakatuh. Thank you, thank you, thank you.
Thank you very much.
Oh yeah,
Thank you
we
so
need
much.
to inform you again about the form attendance. It will be closed at 9:30 or 13:30 p.m. So be ready to fill the attendance form. And maybe that's all.
Thank you for all the participants, and we let you to leave the meeting room.
Thank
Oh,
you
maybe
all the
Lala.
speakers.
Yeah, maybe Mr. Rizky Islami, we could take a picture
Yeah.
together.
Oh, okay. Sorry.
Okay.
Okay. Sorry, we missed
So,
for the picture together.
Welcome.
Okay. All the participants, all the speakers still in this room. I think Professor Yang and Mr. James Zulfan also here.
please turn on your camera and let's take a picture together. Okay, thank you for Weni Suryani, Isan Aris, Sabta Alifatul, and the others. We will take a picture in a few minutes again. Okay. Okay, thank you, all of you. Maybe Mr. Iski Citra Islami could lead us in this
Okay.
pictures.
Okay. Thank you so much all.
Thank you, thank you.
Okay.
Halo, Pak Suleman masih di situ?
Okay, thank you to all of you. May all of you have a great life now and after. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Salam warahmatullahi wabarakatuh. Salam.
Assalamualaikum warahmatullahi wabarakatuh.
Tidak tahu.
Salam.
Terima kasih Kak. Thank you very much.
Tidak.
Selamat Pak Adep, Pak Sinti, selamat Pak Adep.
Selamat, terima kasih semuanya pada
Amin.
tim. Selamat Hasan.
Selamat tim, selamat Pak Adep. Ya.
Terima kasih, salam sukses saya.
Ini saya OTW.
Ya, bagus sekali seminarnya tadi ini, bagus banget ini.
Ya.
Isinya juga luar biasa.
Ya,
jadi terutama jadi kita bisa mengevaluasi kurikulum kita Pak Sindu ke depan.
Betul.
Jadi pasca akreditasi kita langsung evaluasi total dengan perkembangan baru. Ya Pak Sindu.
Oh, maaf Pak
Ini
Agus.
belum dimatiin sama ini ya. Terus aja, biar aja.
Oh sekali Pak Agus, karena mungkin Pak Sindu sedang di perjalanan jadi agak susah Pak.
Ya. Santai aja Pak Adi, ini masih situ Pak Adi.
Pak Adi Kurniawan, iya masih ada. Ada Pak Rian juga.
Mungkin Mas Rian segera dievaluasi apa-apa yang bisa ditulis untuk menjadi masukan ke departemen, Mas Rian. Jadi hal-hal yang disampaikan tadi penting sekali. Notulennya bisa notis yang penting-penting untuk persiapan perubahan kurikulum yang akan datang. Halo?
Iya, Pak.
Ya Mas Rian, notulensinya nanti mungkin dikumpulin untuk ancang-ancang perubahan kurikulum pasca akreditasi. Setelah akreditasi kita harus melakukan perubahan karena perubahan-perubahan di luar sangat banyak sekali, sedang kurikulum kita maupun silabus kita masih 4 tahun, 5 tahun yang lalu. Ya, jadi ini mesti perlu evaluasi yang kencang juga. Tadi saya juga datang di seminarnya di TEDI tentang big data analysis. Itu juga benar-benar haruskan kita mengadakan perubahan-perubahan yang nyata. Baik sekali nanti, ini hasilnya baik sekali tadi, saya dengerin. Selamat ya Mas Rian.
Iya Pak.
Ya oke. Udah kalau gitu. Lanjutkan. Mas Rian, dibantu S2-nya, proposalnya S2 dibantu.
Oh iya Pak, nanti saya sampaikan Bu Detik juga.
Ya, kita selesaikan semuanya karena waktunya hanya sampai Desember. Waktu penugasan. Kalau enggak dianggap enggak serius kan enggak enak juga gitu. Oke, itu dulu Mas Rian. Assalamualaikum.
Waalaikumsalam Pak.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Agus Moreno.
Selamat siang ya semuanya, baik-baik semuanya. Keep in touch ya. Assalamualaikum.
Waalaikumsalam.